Excuse me. Good morning for the second day of our PCI Days. Welcome, and I'm glad that you could make it to the room. I realized that the security was rather tight, so some of you had to wait a bit. But with about 15 minutes delay, let's start our session for today. And we thought that we should start this second day of the PCI Days, which is the one where we go more into the individual topics, with a panel on hydrogen. For those of you who've been here in the PCI Days over the last years, you will have, of course, realized that this is the first exhibition that we have with hydrogen projects. So these colleagues here and their projects are the big novelty, I would say, of these PCI Days. And the background to this is, of course, that we now have for the first time a PCI list in force. We adopted it about a year ago, which indeed includes hydrogen projects. It indeed includes quite a high number of hydrogen projects. We have 65 on our list. About half of them are pipeline projects. The rest is storage, terminals, electrolyzers, so the whole range of technologies. And we selected those projects which are now on the list from an even much bigger number of proposals which were made. So this shows clearly that there is a huge interest from the side of those project promoters who can offer the infrastructure to develop projects for hydrogen in these different categories. Moreover, there's a huge ambition. The majority, about 90% of those projects on the list, have plans to be implemented by 2030. So also in terms of the speed of these projects, there is a lot of, let's say, ambition and goodwill to go forward fast. Moreover, we have a rather elaborate framework already in place when it comes to the regulation of hydrogen. As you all know, the decarbonized gases package was agreed, adopted, and entered into force in August of this year. Member states now have 2 years to implement it. We also have important rules concerning hydrogen, and in particular, meant to trigger the demand for hydrogen in the Renewable Energy Directive. I'm sure we'll talk about this as well. So I think what we can say is that there are quite a number of preconditions in place. On the other hand, today we start from a relatively low, very low base. If we look at what is existing on the ground, we have probably less than 2,000 kilometers of actual hydrogen pipelines in operation. We have about 0.7 gigawatt of electrolyzer capacity, which is commissioned. And moreover, as I'm sure you've also all read, there have been a couple of announcements recently about projects being either postponed or even cancelled. So I think one of the questions which obviously people ask nowadays when they look at hydrogen projects is, is this another cycle of boom and bust, or is it for real this time? Now, I think when you look at our scenarios from the Commission, how we want to get to climate neutrality by 2050, but in effect, we almost want to get there a few years earlier, it's clear that we will need quite a substantive amount of clean hydrogen because we estimate that we will have around about 10% of our final energy demand, which has to be met by hydrogen or fuels. By 2050. So clearly there is a need for this infrastructure. So this is why today in our panel we want to focus on the question how we can get from the regulation that we have, from the targets that we have, to the actual implementation of the concrete projects which you can all visit here in our PCI garden today. So this is the core discussion that we want to have. What are the challenges that you are still encountering when it comes to the implementation of your projects? And I'm very happy that we have a very, I think, interesting and diverse and certainly expert panel today for our discussion in the next hour and 10 minutes. So we have with us, first of all, I start from here, Piero Ercoli, Executive Director for Decarbonization of SNAM. Then we have Olli Sipilä, CEO of Gasgrid Finland. Then we have Marie-Claire Aoun, Director of Prospective and Institutional Relations at Terega. We have also with us Olivia Pilar Infantes Morales, who is Regulatory Affairs Director for Hydrogen and Clean Power at Moeve. We have Piotr Kusch from ENSOC, whom you all know. We have Charlotte Roule, who is the CEO of Store Energy. And last but not least, we have Ralf Barke, Vice Chairman of FNB Gas, and also Managing Director of Ontras Gas Transport. So as you can see, a very diverse panel reflecting hopefully quite completely the regional but also sort of technological diversity of the sector. And I will start right away with the first question. And I'll start with Marie-Claire. So as a first speaker, and given your experience with the H2Met project, what, in your view, are the most challenging aspects of implementing hydrogen projects of common interests across the board?
Thank you, Joachim. Good morning. So indeed, our H2Med project is it's the fruit of a political agreement concluded between head of states of France, Spain, Portugal, with the support of Germany and also with the support of the European Commission. So there is a strong political support behind our project. And as TSOs from Portugal, REN, from Spain, Enagas, from France, Gertegas and Terega, and from Germany, OGE, we have been developing the project since the end of 2022, and we are progressing quite well on this very challenging project. Indeed, the challenge is related also to the fact that we are developing the whole corridor. So we are talking here about 5,000 kilometers of new pipelines going from Portugal to Spain, France, and Germany, and 700 of kilometers of repurposed gas pipelines. So including all internal H2 backbones in all those different countries, plus 3 interconnections between Portugal and Spain, CELSA, between France and Spain, so Barmar, and between Germany and France on the interconnection point Medelsheim. The idea is to transport 2 million tons of hydrogen per year, which means roughly 10% of the European plant consumption of H2 in 2030. So I would say that one of the challenges is to coordinate the development of this whole corridor. Of course, we have the traditional challenges related to the engineering part, and now we are doing the pre-FEED, and this is progressing quite well, I have to say. We need clearly to develop a coordinated approach between 4 countries, 5 TSOs, in a nascent market. As you said, Joachim, today we have limited demand of H2, limited production, but we know that the ambitions are high, both at the European level and also in our different countries. In the Iberian Peninsula, strong ambitions of H2 production, competitive H2 production. France also has a true ambition in this area, in hydrogen, both from the production and consumption perspective, and also a lot to Germany, and probably we'll talk about it later. So really the idea is to link those main consuming areas in Europe, mostly in Germany, with the important potential of the Iberian Peninsula in terms of production. So if we come back to the challenge, clearly today we really need to project and anticipate this future development of the market and develop the infrastructure, which has a long lead time, not completely the same time as what we have for the asset for demand and for production. So really this is the key challenge for the development of infrastructure on this long period. All this in a framework where we do not have the regulatory framework yet. Yes, it is done approved at a European level, but we need to implement it at a national level, and it's not the case everywhere. And so this needs, the framework for H2 needs to be implemented at a national level to give visibility to the investors, but also at the same time have a coordinated approach to develop properly and coherently the whole corridor. And also, of course, another challenge, key challenge for us is to build the financial model. Financial model, it will be built probably a little bit on public funding, a little bit also on long-term commitments from the market players, but we know that this will not cover everything. So here again, we need to find regulatory mechanism to take into account also this temporal specificity of the project. And another maybe challenge, but we will probably have another a longer discussion, is related to the permitting and to the acceptability, because here also again we need to align all the permitting processes along all these countries, and also have the right public consultation framework in all our countries, and yes, to promote and facilitate acceptance. So this is all ongoing, and just to finish, we are launching a call for interest in 2 days, on the 7th of November, in order to have really the right feedback from the market on the whole corridor, both for the production and the consumption side on the whole corridor in the 4 countries.
Thanks very much, Marie-Claire. I think already clear from your statement that there's certainly a big challenge in terms of coordinating all the separate processes and elements of a value chain and a market which still has to evolve. Now, with this in mind, of course, one of these sites, let's say, which needs to be brought in is the potential supply. And here we come to the electrolyzers, and this is why I'm very happy now to give the floor next to you, Olivia. Can you tell us a bit about the challenges in implementing electrolyzer projects at this point in time in particular?
Okay. Thank you, Joaquin. Well, first of all, thank you very much for inviting us to be in this PCI Days. And in Moeve, if you know, we were formerly CEPSA. We are green molecules developers, so being the different animal here in this panel is a huge responsibility for me. Well, in Moeve, we are developing the Andalusian Green Hydrogen Valley, where we are intending to build 2 gigas of electrolysis capacity, 1 giga in Huelva, 1 giga in Algeciras, near the Strait of Gibraltar, in order to decarbonize our own activity, the activity in the industrial area where we are located, and also to produce green molecules, ammonia, methanol, SAF, in order to sell it as fuels in the Strait of Gibraltar, or even export it. And for that, we have established agreements with the Port of Rotterdam, and we are working in the north of Europe in order to be able to take the molecules there. In order to illustrate where we are today, I'm going to focus in the more advanced project. That is the one of 400 megas electrolysis capacity in Huelva, together with Fertiberia, to decarbonize our own activity and to produce ammonia for them, and also for the maritime sector, as I have said. We started the permitting process last year, beginning last year. This year we have received the environmental license. That is one of the most difficult papers to receive. We got it. And regarding electrolyzers itself, we decided to work together with ThyssenKrupp for alkaline technology and Siemens for PEM technology, because we are going to combine both, because we consider, as I will explain you later, that it's very important to be able to provide flexibility to the power system. So that's why we are working with 2 technologies and European manufacturers, because we really consider that we have to push for the technology to be developed here in this initial phase of the market, let's say. That's where we are. Which are our main challenges? I'm not going to talk about regulation. I'm not going to talk about public funding, because in our minds it's clear that we need it. I'm going to go to the real details of what we are facing. First of all, committed demand. We have our own demand, because we are the second main consumer of gray hydrogen in Spain, so we have our own demand. We have the demand of our partners, Fertiberia and other industrials in the area. You can look at Google, where 2 other customers there in Huelva and Algeciras, and you will see that there is a huge demand there. But we are developing a larger scale project, because we consider that is we have done our numbers, and LCOH is better when you go to big scale. And the fact is that the rest of the production that we have doesn't have a committed demand to take it. So from our side, it is key for all developments in Europe to be able to have that demand. How? With clear targets in the regulation. Clear targets, and I would say that also with a CO2 price leading to real take decision on decarbonization projects. So CBAM is there, it's true, CBAM is there, but I would say that is an initial tool to start working on this global CO2 price, and global and leading to decarbonization, real decarbonization. Second issue, so first issue, committed demand, second issue, power costs. When we talk about power costs, we always think we have to find cheap renewables. Of course, cheap renewables are basic. But when you go to the total cost of supply, there are not only renewables, so the electron price, there are regulated costs that we have to be able to manage. Which kind of regulated costs? Of course, grid access tools, very important. And there are also other regulated costs, as for example, maybe this one is also market-based, but it's a regulated cost that are ancillary services. We have to, if we really want to get an interesting and competitive LCOH, we have to be able to reduce that regulated cost, meaning reduce the grid access tariff, but also allowing to the flexible projects to participate in ancillary services as generators. Because what we are seeing with our partners in the manufacturing of electrolyzers is that electrolyzers, with the proper design, electrolyzers projects can be flexible and be active participating in ancillary services. Of course, previously qualified by the TSO, of course, as all the units participating in that services, but it's possible. Okay, so two things. The last one, and I would say that is the most important, that is grid connection. Yesterday, the message was clear. There is a scarce resource here that is the grid in general. And it takes time to develop the grid. So if being able of connecting to the grid, being transmission and distribution network, it doesn't mind. If it is a challenge and adding new capacity to the system is complicated because development takes a lot of years, it is necessary to somehow decide how are we going to allocate the capacity that is available today in the system. It is true that there are a lot of requests coming from data centers, storage, and big hydrogen projects. It's clear. Somehow, at national level, at European level, has to be decided how to properly allocate this capacity in order to make projects a reality and to fulfill the targets that we have at the European Union. Thanks.
Thanks very much, Olivia, and thanks also for pointing out the interlinkages to the electricity system and the discussions that we've had yesterday on electricity market reform, but also infrastructure in particular. This is the very reason why we have both hydrogen and electricity in our framework, because indeed these interlinkages are very important. So thanks for that. Let's perhaps now turn to another region, to Northern Europe. So Olli, I'm turning to you. What can you tell us about the developments in the Baltic region and what is missing there to get towards a fully functional hydrogen system?
Joachim, I would start for perhaps a bigger picture why we are doing it. And I was actually in a conference last week in Germany, in Düsseldorf, and I started to speak there with the question that what would be the current size of the German car industry if we would have decided to first build the cars and then the roads. So this is the key item for we think that if we are able to create a platform of electricity grid, methane grid, and then new hydrogen grid. To enable these type of growth in this green transition, we can enable a European competitiveness, as pointed out in different reports, and I guess everybody sees this today, what needs to be done. When it comes to Nordic, and I'm now speaking about the Baltic Sea region, I think it's a very strong region with some unique features. So if I start with the renewable electricity potential in the region, it's vast. I heard that yesterday there was a discussion of certain offshore wind projects to be blocked by the military reasons. Okay, if we start building the onshore wind, what's there, onshore solar, what's there, remaining offshore wind, what's there, when we get to those projects which are now blocked, it will be my children's grandchildren who are building those. So there's a massive amount of potential. So I think that's something kind of which started as a starting point for us to develop the region and the corridor project in particular. One feature in the Nordics is that its majority is new build, because the current gas infrastructure is not as huge and connected as in continental Europe, because we have been an electricity-wide region and the local connection district heating-wide region in the past. So it will be a new build. But of course, hydrogen pipelines, electricity grids, all is new build. And I think there's a good synergies, because you can do planning, and I guess the current regulation is looking forward to integrated planning, which is extremely important. Then these two technologies are bringing unique features, and I guess there the hydrogen, one unique feature is that with one pipeline of 1 meter diameter, which is underground, you can replace even 15 overhead transmission lines, which take each a 150 meters space. So capital efficiency, building efficiency, land use efficiency. If we can deploy all of these grids in a faster scale, I think that's a good thing. And in the Nordics, we have space to do so. So that's a specific feature we are now trying to tackle. And of course, we have in a region a very strong historical cooperation in cross-border infrastructure. This is not necessarily a fact to undermine. We know what works, what not works. We know how things work. So I think that has shown already a good progress in the projects we had in it. But building on those starting points, I think there was a lot of Olivia and Marie-Claire's comments also. What I will also address. We need to first of all assure the demand side pull. If the demand starts to pick up, I think the infrastructure and supply will go up. That's the key. And let the market work there. At this point, there's relatively high option value for suppliers and users to wait. Okay, will the regulation change? Will I get better terms in the next year or next year after on the regulation or my sourcing contract of electricity or electrolyzers or so forth? So we need to make sure that the early movers are not penalized of their risk-taking at the moment. So having systems like grandfathering or something to enable this first growth is I think, an important when we implement and change the regulation. Then what we have learned already, we need to recognize the country differences. There's different countries. Some of them are demand heavy, some of them are supply heavy, some of them are transitional. How we build this cross-border several country structures to enable investments, I think that's the same topics we have there. And I think one solution is the regulatory flexibility. I think the EU gas package gives a lot of good tools already there, if we implement it in a right format, in a flexible way in these complex projects. There's TSOs, there's suppliers, there's users, there's NRAs, there's national ministries, there's a ACER, there's a commission. We need to get all of these in a flexible way to the end, that the early movers do not pay the burden of their risk-taking. So I think that's something. And then in the Baltic Sea region, we have a PEMIP feature, which has worked in the past. So there's a lot to build on the past experiences. So those would be my kind of starting points, that what we have learned already and what we can build on later on.
Thanks very much, Olli. Thanks also for raising the non-trivial question, what should come first, the cars or the roads, so that in the end we have both. I think that's a good picture for the, one of the problems we have to address. You spoke a lot about the, the very high potential that you have in your region. So let's perhaps now turn to another region where there is certainly a lot of potential, which is Southern Europe, but not also Southern Europe. Also, some of our neighboring regions have, of course, a lot of potential. And this is where I would give the floor to you, Piero, to tell us a bit about your experience with the Italian hydrogen backbone and the issues that you have encountered in setting up such a complex cross-border project, potentially also including a link to neighboring countries.
Okay, thank you for the invitation. And of course, I'm speaking as NAM, but of course, the South H2 corridor, as you can see in the PCI garden, it's a combination of different TSOs. So NAM from Italy, of course, TAG and GCA from Austria, and Bayernetz from Germany. I would say on everything that said Marie-Claire, I think it applies to us more or less, so I will not repeat things which are the same. I will probably give you a different perspective in terms of the fact that PCI are also a very good trigger inside the companies to every year to do more. So when we started, I remember, I joined the hydrogen team and then I became responsible for this unit. And immediately we had 2 PCIs because I'm also responsible for CCS. So the first year was really kind of jumping a little bit into an empty space, because it was new for everybody. Of course, we had the strong experience on gas, but these are quite different beasts, I have to say, because in gas you have everything, right? Here we need to build the market, and so it's quite a different topic. I think 2 years down the road, this round, it's a very different picture. We have learned a lot about ourselves, about our projects. There's been a lot of an increased collaboration. So every year we have at least a couple of round tables with the government of Italy and Germany and Austria, and they have created this, this platform which brings together TSOs, regulators, governments, but also demand. And I think this is going to evolve into also five-a-side type of meeting, including Tunisia and Algeria. So this platform gives a lot of strength to the project because allow us to enter into the discussion about the topic that Marie-Claire was saying before. How do we aggregate demand? There are certain countries that have done a very good job in creating platform. For instance, in Austria, there is an alliance looking at hydrogen. You can replicate these models into other countries. We did the market test in Italy, so we discover quite a lot in terms of industrial demand. And the industrial, they have a lot of questions. And sometimes when you get into the detail, you discover this thing about, okay, with hydrogen, you need to change everything. Well, wait a minute, it's not true. When you go into the detail, you discover that basically on some application, maybe you can use 20%, 30% blending inside, which is a big point, because if you don't need to change also the industrial application, it's a big advantage. So we're now doing a lot of work also on the demand side. So we have a team really looking more at the technology and collaborating with this. Then, of course, there was the CEF call, and this triggered the work on the engineering side on the Italian backbone. So we are now entering into a very detailed analysis of the entire backbone and looking at every piece of infrastructure and talking about H2 purity, what type of compressors, which I'm pretty sure there are all the questions that a lot of other people will have to face. But it's good also that there is a broader collaboration at European level, so this thing can be discussed in a broader context. If we move to Africa, which is going to be PMI application for us, then that required additional work. I think Tunisia started very early, so we had a very good collaboration since the first call. We were not able to submit a PMI because we were still in the process of acquiring our share in Sea Corridor 2 years ago with DNI. So a lot of work was already done. This year we started working much more intensively also in Algeria. We signed an MOU recently with Sonatrach. So as you see, the way I look at this is that every year you need to do like some steps. So it's always like a marathon, and you need to run a marathon at the good pace. No, so that's for me the important thing. So to be honest, I don't look really. I look at the challenges. I'm not disregarding the challenges, but there are a lot of things you can do to still progress your project and go ahead. And then complement it with additional, links, with additional topics like storage, which is a huge topic. In Italy, we are the biggest storage operator in EU. We manage 200 terawatt hours of storage, but of course, we have depleted gas fields, which, are quite complex assets to transition. Let's face it. So, but if you put every year, you're addressing, you're understanding one thing, then you can do the next one. So I think we are very happy that the government did also the hydrogen strategy this year, because the Southeast 2 corridor is going to be for sure a central part of it. And then we look forward to PCI, PMI, and CEF results, which are very important for us to continue the journey. And of course, I think now we expect also the regulation to come down and to discuss with our regulators how to implement this. But the discussion on the Southeast 2 corridor was very instrumental to already start the discussion up front, because as I said before, regulators are also part of this trilateral discussion. So all in all, I'm very happy with this year, and I think we need to be optimistic to do this type of project now. Recently, I did, since you mentioned before, I did a presentation to our board. When we look at hydrogen, we need to be realistic. I don't know why people are always fingering to things which are going wrong. There are a lot of things which are going well. So the number of FIDs have increased, not decreased, contrary to a lot of other people. This is what the numbers are telling us. So of course, it's not easy, But I think sometimes, in this period, we were probably too optimistic before. I have the impression we are rather too pessimistic right now. So we need to be a little bit more balanced in this. Thank you.
Thanks very much, Piero. Thanks also for this message of optimism, which is well received. And thanks in particular also to linking it, let's say, to the PCI label and our framework, because of course we do hope that this can have this catalyzing effect that you mentioned. So since you mentioned storage also in particular, perhaps if you allow me, I would now turn to Charlotte to go a little bit more into the storage subject and tell us about your experience with the implementation of storage projects, which I think everybody agrees will be an important part of the emerging value chain in hydrogen.
Yes, indeed. Thank you very much, and thank you for the invitation. It's a great pleasure to share about our project and about our experience on projects of common interest. And maybe I'll start with a few facts. You remembered us, Joachim, that actually we have, let's say, a bit less than 2,000 kilometers of hydrogen pipes currently in Europe, privately owned. We have 0.6, 0.7 gigawatt of installed capacity for hydrogen production when it comes to green hydrogen, etc. We have no underground hydrogen storage. So there is not a single underground hydrogen storage so far in Europe. And actually, when we come to the PCI process, there were 7 projects of underground hydrogen storage that were recognized at PCI, PMI. So it's really something that is starting, and we are working on interconnecting. And so obviously it is a question between countries, but it is also a question between infrastructure. Oli, I very much like your comparison between, or let's say, comparison with the roads and then the cars, what comes first. Storage is an essential part of the system. So we are developing projects of underground hydrogen storage anchored in France and Germany. And actually, in terms of technology, this is something that is going on. So obviously, there is a whole supply chain to be built, but we are working on that. And so you mentioned H2 purity, Piero, and then also the question of compressors, etc. Obviously, that's thing that we are working on, and that's our job as industrials. But then, that's why I would like to take you a bit in a more wider picture. How do we develop further hydrogen storage? What is important for the system, and how do we approach that? And the first point to me is really to understand how we approach the benefits borne by underground hydrogen storage. So this is a question of cost-benefit analysis methodology. How do we work on that? How do we make sure we have the values of flexibility and security of supply that are recognized within this analysis? And this will make a huge difference in terms of pushing further underground hydrogen storage project. We really need them, and so far, when I was mentioning the project that were awarded as PCI, and that's really a great news, we are working on a very limited amount of terawatt hour. And if you look at the infra map, you will see that we have 9 terawatt hour of underground hydrogen storage projects that are planned. Hopefully they will happen. While we did a study within Gas Infrastructure Europe with Artelis and Frontier Economics, and we would need 45 terawatt hours by 2030 if we want to achieve the objective of REPower EU. So there is a huge gap that we need to address, and the first point is to recognize the value of underground hydrogen storage. Then the second point I wanted to mention is really that we need to recognize the value, or actually have a joint approach, and that's where I go further from your analogy with the road, approach together electricity and hydrogen. We need to explicitly link hydrogen with electricity. They are both parts of the same story, and we can observe it. For instance, I was mentioning Germany. When you look at how much renewable power is curtailed in Germany, I mean, the figures are public, so it's no secret. The cost of network congestion, this is really something that we need to address. And why do we need to address it now on an orderly way? It's because actually it takes time to develop underground hydrogen storage. So really having, an explicit link and with daily and hourly granularity, this is something that must be done for underground hydrogen storage, bearing in mind that underground hydrogen storage will not be used as underground gas storage. Sometimes I can hear that kind of thing. You need to wait for the market to be there. You need to wait for, arbitrage to happen and that kind of thing, and there will be seasonal needs. No, it's not what will happen with hydrogen. We are really complementing the electricity system. This is a question of the energy system as a whole, and that's how we need to approach. So we would like really to have the EU Commission and SOG, so I'm looking at Piotr as well, I know he will speak later, to work on dynamic indicators. But I think it's important that we go through all elements to show the value of underground hydrogen storage and then decide what we want in terms of volume. One element I wanted to mention as well, the project we are working on, you were mentioning, Piero, depleted field. There is a lot of research ongoing, but it's true that in Storengy, what we develop is storage in salt caverns. What it allows us is to have adaptability to the demand, a growing demand, hopefully, and scalability. So we can develop or convert, depending on what we are looking at, to underground hydrogen storage at the pace of the progression of the demand. So that's quite important as well to have that in mind, so we don't overinvest, but we can really adapt as much as possible. And then, obviously, all this comes with an interlinked modeling approach. So I was mentioning electricity and hydrogen. I think we need to have gas in there as well. And why do we need to have gas? Because actually, being a storage operator, the first question I will have, and we are now in the winter, is, are your storage full? It's not, are you ready for hydrogen storage? Which is still a very good question, and I should have it more often. But the main question is, are your storage full? Are you ready for this winter? So how do we make this orderly transition? How do we plan it on a coordinated basis? This is what is important and what we can bring further if we want to, have even more projects of common interest of underground hydrogen storage, because they will definitely come and support the EU approach in terms of energy transition. I mean, limiting the curtailment of renewable power. Again, this is really much a question of power, not of gas. This is not that much the point. And then really rethinking about the whole system. We need to take also counterfactual scenarios just to make the analysis more robust. What if we don't have any underground hydrogen storage? And what if we have some? And again, I want to insist on the fact that we need some time to develop storage or to repurpose. It will be not the same time, but it's 5 to 10 years. So we cannot, at the moment where the importance is recognized, say, well, okay, no problem, within 2 years we'll be there. We won't be there within 2 years. So at the end of the day, what I can share on that is that we are going for project of underground hydrogen storage. We are very much, I agree with you, Piero, it's very positive, and having some PCI, in a way, labeling, if you allow me this expression, is very positive. I wonder if we should not have signaling mechanism even clearer, like hydrogen PCI or underground hydrogen storage PCI, something like that, to push even further. But then, as storage operators, what we can do is see what we observe on the market. And then we bring something on a local, as wide as possible, but still local basis. If we want to have an orderly transition, respecting security of supply overall, but also the flexibility needs, and at the end of the day, the energy security of the EU, then we need to have this coordinated approach. Thank you very much.
Thanks very much, Charlotte, for both pointing to the the value of flexibility and the certainly challenging task to measure this correctly, but also to the challenges of actually doing a transition which ensures that there is security of supply, not only in the new system to which we will transition, but also in the system that, of course, for a while will still from NSOC, to tell us a bit about how you as an association can help project promoters globally, but also specifically with regard to these two issues that were raised, so flexibility on the one hand, but also on the other hand, managing this transition.
Yes, thank you very much, Joachim. Maybe it's very challenging to be the fifth or sixth on the panel, because there are so many interesting remarks that I would like to also relate to. So I'm really glad that we are having this panel today and that we discuss molecules and their infrastructure, because I think that the starting point for us is that we have to have this recognition that we need molecules and their infrastructure to develop neutral, zero carbon energy system of the future. We are fully aware that as we discuss and we'll discuss, electrification of our system is progressing, but we will need molecules to start even now balancing the system with natural gas. We have to have the storage over seasons. We have to have the storage also to provide stability and security for the winter time. And then we have to be prepared to provide this energy system integration and interplay between molecules, hydrogen, and then increasingly even CO2. So every possibility that is at hand we should use. So this is, I think, our first remark here, and this is the way NSOC has been working and is working to really provide for this energy system integration when we look at the infrastructure, so these roads that are very needed. Then to you, Joachim, you said, is it for real? Are these projects for real now? And I think, as also Pierre mentioned, there is too much pessimism, but of course we live in the world that good news is no news. So basically we always try to relate to some breaking and bad news. So I would say this is for real. And on the top of TYNDP we work, I would like to relate to our hydrogen infrastructure map that NSOC and a number of associations for infrastructure on transmission, but also other and distribution level are developing. And yes, we have over 500 projects currently in the different parts of the value chain, starting with transmission, storage, distribution, receiving terminals. So we have this progress, and we see the progress. And we also want to work in the evolutionary manner. And of course, it's very important also from the processes that we are taking in Europe. And if you look at the TYNDP process, so very very challenging 2-year setup that we have to follow, and we are following for years in this manner. We already see how this process is adapting to the new challenges. 2020, we introduced already the energy transition projects category. 2022, so the first DYNDB process that was including and was designed for the new 10E regulation, where we have already designed the PCI list with no fossil projects, has collected over 200 projects for transmission, reception, storage of electrolyzer and mobility projects in the category of hydrogen. So we see gradual inclusion and gradual significance of the projects. And now in this current edition, we are capturing even more interactions between hydrogen, natural gas, and the electricity sector. This is very important to design the system of the future and to really look at all the possible interdependencies. And then it will also help to structure well another PCI round. So the projects that we are now also experiencing today in the room. Maybe one thing more on the top of how we can look for efficiencies in this processes. And of course, we were discussing this need for speed. We are fully aware that the challenges are here and now, but it will take time. But I think one of the important aspects for let's say looking and capturing the interdependencies between infrastructure is to look at how we can already use existing natural gas infrastructure, how we can repurpose that to serve the new gases, to serve hydrogen. And we see that this is the process that should be continued, should be analyzed. And on our side, as NSOC and other actors, we are also contributing to showcase and to look at the criteria that are needed. This is one of our tasks already, cooperating with pre-NOH, with Acer, and other stakeholders based on the conclusion of the last Copenhagen Forum. So this is something we would like to showcase. And of course, repurposing should be also strongly focused, because this is a process which is technically feasible, which brings a lot of synergies in terms of financing and speed. But it's also very important from the factor of security of supply that we mentioned here today. So whatever we plan for hydrogen, whatever we look at how this part of the system will develop, we have to really closely analyze that with how gas and natural gas system is functioning, especially in a short and medium term. This is what I would like to relate here. What was said by Charlotte, that we have to be ready for the next winter. We have to have the stability over the seasons in the years to come. So we have to have also this impact for preparing our infrastructure. And yes, we remain optimistic about the prospects of the energy transition. Optimist to the extent that it will include the role of molecules.
Thanks very much, Piotr, for bringing in the point of view of NSOC and also pointing indeed to the role of repurposing in that context. So I think now, last but certainly not least, I would turn to our last panelist, Ralf Barke from ONTRAS, but also representing FNB. Now, you come from Germany, and Germany is obviously a country, to which many are looking, specifically for the question that all of you have raised. Where's the demand going to come from, and how is it going to be firmed up? Now, you're not from the demand, but perhaps in your explanations on how your project is going forward and what challenges you encounter, you can also discuss a little bit, let's say, how you see the demand evolving and how indeed we can come to a situation where we move to actual concrete contracts being concluded.
Yeah. Thanks for this introduction. Yes, of course. I would start with a very optimistic and good sign for today, and it means that in Germany 2 weeks ago, our national regulator has given the final approval for the German core grid. What this means for the audience For us, I think it's a real major milestone to develop the hydrogen economic in Germany as well also in Europe, because with this approval, we are ready to, well, we set up in Germany a real framework to start to build a core grid around Germany with 9,000 kilometers long. It's a huge one. We have an injection capacity from 100 gigawatt, and we can transport over the year hydrogen with an energy equivalent of 280 terawatt hours. That means that 1/3 of the energy amount that we need currently in Germany with the natural gas. And we will finalize this building periods and go in operation with most of them in 2032. And it will be cost only 19 billion euro. But I think comparing to the electricity market, it's very cheap. But I think it will give us also a very good connecting point to all the neighbor countries in Europe areas. And we heard a lot of projects they could connecting to this. And with this core grid, we create a real demand focus within the European Union. And as you know, in Germany, we are not ready to all produce all the hydrogen that we need in Germany with our own equipment within Germany. The most studies plan with the numbers of more than 60 or 70% for import of hydrogen. And therefore, it's so important that we have such an anchor point within the European countries and create this decision that we have. Of course, I think it was a wise decision for the German government to say, we will solve the chicken eggs problem that we see in such a ramp up of a new business, with the idea to fix the framework for the infrastructure and create this infrastructure very, 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 very fast. And then we hope, and we are very keen that it will be function, that we will see that also the demand will increase in the same direction. And of course, you know, the German government, the German TSOs are regulated TSOs, and the special question for this is how it will be function. That means in the beginning of such a period, we have to invest a lot of, or we have a lot of investment costs, and we couldn't bear this with the income transport fees for the customers, because we won't see in the first stage so much customer they are willing to pay such high prices that we need to cover all these costs. And that's the special solution that we together with the German government developed. That means the amortization account. That's the key for this, and that means in the first stage, if we could not earn enough transport fees for the customers, we get the money back for the governance. And of course, the systematic behind this is that after a certain time, the customers are ready to pay more than in the first stage, and that means we equalize this account over the time. The most of you would like to ask me what will be happened if the ramp up not will be follow this. Of course, we as a normal investors, and we have to collect our capital also for the normal capital market, and it was a very crucial time, crucial question. And the rules behind this is if we not equalize this account up to 2055, it's a long period, but if this not the case, then 76% of the rest will be covered for the government, and 24% will be covered for the TSOs. It's a real risk, of course, but we could mitigate this, and we have all to work together to make this happen. And then we hopefully could equalize this risk in advance. But I think it's a very good model, financing model to mitigate this risk. And I could thought that we will have equal systematics, maybe also in other areas in Europe over the time. The last point, what I mentioned here is, of course, we could mitigate this risk. It's a very good thing. But on the end, what we see, we have to invest huge amount of capital. And if we look around Europe, we are not alone. We have the electricity side. We have all other sectors. They also ask for capital. And so we have a real competition for this. And that means only the risk mitigation is not enough. We have also look at the interest rate that we, as regulated TSOs, could earn for this. But I think that will be the question for the future. Now I think it's time to build this core grid and to bring it ready and in operation, so that we could use a lot of them. And if we link maybe to Piotr's speech, 60% of this core grid will be repurposed. That means we will use existing natural gas pipelines for this. That brings us a big advantage for the speed to build this, to repurpose this, and also for the costs. We have a very similar project at the moment that we will finalize mid of next year. And the repurposing of a pipe, we could confirming that we only need 20 to 30% as a new build pipe, and that's a big advantage that we will see. Yes, that's my good news in the rest of this queue of very interesting speeches. Thank you.
Thanks very much, Ralf Barker, also for this view from Germany and for explaining how, in a sense, Germany has already taken perhaps one step further in enabling these investments through the regulatory framework. Many questions, of course, which come from this. But given that we have only about a quarter of an hour left, I think I would perhaps want to open the floor now immediately, because I'm sure, I certainly hope, that the contributions of our 7 panelists have raised a number of questions, perhaps also critical questions from the audience. So I would now want to open the floor, and please raise your hand if you want to come in and introduce yourself and say to whom you would want to ask the question. Do we have anyone who wants to break the ice? At least from here, I can't see anyone, which is maybe because it's dark, but it's maybe also because it's early. And if that's the case, then perhaps I'll continue from here. And perhaps building on what Ralf Barker has explained about how the regulatory system in Germany has evolved, I wanted perhaps to put the question to the 3 of you, because the 3 of you are working on, as one project promoter, on projects which are going to span several jurisdictions in and potentially outside Europe. So how do you deal with the situation where you have, as we've heard, a European regulatory framework, but you have a transposition phase, and in that transposition phase, presumably you will want to take your FID at some point, and you have different regulatory frameworks along the corridor evolving potentially at different speeds. So what is your way of dealing, let's say, with these issues in order to move forward nevertheless? And perhaps we'll start with Marie-Claire.
Yes, it's true that it is one of the key challenges, actually, to progress in the projects in this current uncertainty, if I may say, on the regulatory part. So the topic is key for major infrastructure projects, and as Ralf described it, there are some mechanisms that are currently put on the table, but then we have on our project, and probably it's the case for the others, also to add another point, which is that the beneficiaries of the projects are not always located in the same country. So clearly there is a need to have a real discussion between the countries all over the corridor, because the main beneficiaries of the H2Med project, they will be in France, in Spain, probably, in Portugal, but many of them are in Germany. So there is a need to design this regulatory framework between the regulators. So how do we deal with it? It's a dialogue, it's a regular dialogue that we started and that we have to do more intensively in 2025 between the regulators, the member states, the TSOs, and also building on the call for interest and on regularly testing the market. We think it's important to have the feedback from the market in order to really design the project that is meeting the future market needs. So yes, I think that at this stage it's to add, as also it was said for South H2, really the idea is to have this regular dialogue and through this key project to start indeed progressing in the implementation while coordinating with all the other countries. And it's key because if we want to be to meet our target in 2030, we need to take FIDs in 2026 or 2027. So it's key really to progress in this framework. Yeah.
Thanks very much. Perhaps turning next to Olli, you also mentioned already the role of BMIP and regional cooperation in your introductory remarks. So maybe you can also come back to that.
Yeah, I really would envisage, as Marie-Claire, this kind of collaboration between the regulators early enough, between the ministries early enough, and of course the companies. That's the key kind of. There will be national regulatory differences, I presume, but how to connect them in a financeable way, I think that requires time. So you need to start yesterday on that. And I think like Ralph put it on, there's new innovations coming which are actually financeable, country specific at this point, but there will be other ones. So how we learn from those and perhaps to do it in a different context, in a different places, but learn from them is, I think, a promising direction. One item we didn't speak in this, that all the regulators, all the companies know how to do the financing models. You put the supply and demand and capex and opex and returns, and you put the prices and all that. But how do you price and value new features of economy or a society, like a security or strategic autonomy? How you create market mechanisms on those? I think the flexibilities and all that, we need to work a lot on those, and there will be good value there. For example, there was a very severe situation in the Finnish electricity market on the first week of this January this year. And gladly we had implemented a floating LNG terminal to have the gas capacity there. And we backcasted that what would have been the cost to the society if we wouldn't have been successful implementing that floating LNG terminal, because we didn't have a Russian gas or the Baltic connector was down. The value of that 1 week, the flexibility, was 1.5 to 3 billion euros for the society. The flexibility value, what was, if there wouldn't have been the gas system. So how we value these kind of flexibility values, how we value security. So all these also on the regulatory models, I think these innovations are needed to speed up and find the financing conditions. So that's one addition I would make.
Thanks a lot. Piero, same question to you.
I would say for us, it's we look at this in the context of what I was telling you before. So these trilateral meetings, we have been already exchanging views about how this is going to work. And of course, as Marie-Claire was saying, I think it starts from putting numbers on the tables in terms of demand, in terms of initial phase. I mean, let's remember one thing which is very important. Transport cost, it's negligible cost, almost negligible cost versus the final cost of hydrogen. So the disproportionate effect of having access to high quality resources, in our case, the one that are in south of Europe or in North Africa, outpace completely the cost of transportation. And even more in our case, because we are in the same situation, we have redundancy of infrastructure because of the way Italy has been supplied. Therefore, the percentage of repurpose along the route of South Corridor is quite high. It's similar to one of Germany. So this is a very important thing, because at the end of the day, what we hear from industry, we need to have competitive cost. Otherwise, people, and that I'm pessimistic in that case, people are not going to switch. So that you see now that people are much more strong on this point because of we don't want to have the industrialization in Europe. So so you start from the numbers, and probably you're going to have a different mechanism. I think you can use instruments that have already been used. Incremental capacity is a system that you use in gas, and you can use it to do a more formal approach than a market test that we did. Of course, then we have the part of the offshore and the part which is outside the European Union, which will require probably a different treatment. But at the end of the day, for sure, we will need long-term booking of capacity. The mechanism in which we need to translate this into customers is not dissimilar, in my opinion, to what we had. I mean, I used to trade LNG. It's not dissimilar to a big LNG project, right? So at the end, you have to have idea one big LNG project, you need 70%, 80%, depending on the project or the risk you want to take, long-term commitment. It's not dissimilar in this case. So I think, as Marie-Claire was saying, we had already very good discussion this year. I think next year is going to be the time where we're trying to fine-tune this discussion, and probably we're going to have a slightly different discussion in the let's say onshore part and the out of Europe part. Having worked quite a lot with Germany, there are also instruments, the H2 Global instruments, or the hydrogen bank instruments that can be used and adjust to this type of situation. So I think we will need a little bit of everything, but for sure we need demand. It's a big point. But the benefit of doing cross-border is that if you pool in 3 countries, it's easier to get this pooling effect of demand. So we see it already. So that's a clear benefit of having cross-border corridor, right?
Thanks very much. So I think we heard now from the 3 of you how, let's say, the market case could evolve, but at the same time here we're still talking about, of course, infrastructure which ultimately should be regulated. And now I would actually like to turn to Olivia and Charlotte, because you are dealing with parts of the value chain which should finance themselves out of the market in the future. And this is why I would perhaps like to ask the 2 of you, how do you see the market case, let's say, evolving for electrolyzers and storage? And what is there perhaps anything still missing in our market framework that will allow you to develop your infrastructure out of the market in the future?
Okay. Well, I would say that regarding electrolyzers, it's clear that as the way the value changes evolve, in the future, electrolyzers will be cheaper. From my point of view, it's clear. Meaning that for initial projects, it's clear that subsidies are required, because if not, the project is going to be operational during 25, 30 years. So if initial ones that are not able to use public fundings, that means that they will not compete in the same conditions that the ones coming later. That's in relation to electrolyzers. In relation to operational cost, having in mind that 60 to 80% of the LCOH come from the power cost, from the electricity cost, a huge effort has to be done in order to be able to reduce it. I'm not talking about subsidies. I'm talking about public funding for that operational cost. Is thinking on ways of reducing the operational cost to produce electricity, meaning reducing transmission tariffs, because these customers are going to be huge, not electro-intensive customers, huge electro-intensive customers. For example, in Spain, an electro-intensive customer is that consumes more than 1 gigawatt hour per year. Our project, the first sub-project of Huelva, will be consuming almost 3,000 gigawatt hour per year. That means that we are not a big customer, we are a huge customer, meaning that with reduced tariffs, the incomes from the system we will be really high. So from my perspective, we have things to do on that. And we cannot forget something, that is, we are competing worldwide. Of course, we need infrastructure if we want to import H2 molecules, hydrogen, not only H2, but ammonia or whatever is going to be the vector. But the thing is that we have to have in mind that we have to compete. So if we are not able to create a framework allowing to get an LCOH competitive, then will be the investments will be out of Europe. The hydrogen and the molecules will come from outside of Europe, and we will not be able to create the value chain that we are trying to develop in Europe.
Thanks very much, Charlotte.
Thank you. Well, for storage, actually, we can observe right now some differences. And Ralph, you were mentioning about Germany. So there was a study by Frontier Economics for BDEW. So that's, an organization that you know, obviously, from Germany, pushing some system like contract for difference and also the amortization that you were mentioning. So that gives a shape that allows going further in terms of FID, because indeed there are more FIDs, but in underground hydrogen storage, it's still quite, let's say, modest, if I can phrase it this way. So we really need to have this view of what is the country, and that's where then we may miss the point of interconnection you were mentioning, Piero. So between how do we make value for the whole of Europe. So it's very much a country per country approach that we see for the moment. So so that question of what system might be in place at which point in time, and you were saying, well, we look for the market, but we also look for, in a way, the regulators, or at least they are coming to us to say, well, what is the system we could put in place and at which time? And that's the most important. So Germany is clearly among the most advanced. Some other countries are less and waiting until 2032, 33 to discuss or to be ready. So that might be a bit late if you want to have storage at that point in time. Again, 5 to 10 years to develop or convert, depending. So it really depends on what we see to go further and to accompany. Then if I take some use case, just to give you also some elements that would be more immediate, definitely we had in France a consultation on hydrogen and notably on electrolyzer, and we can see that there is a trend coming. We'll see if it's really confirmed to support more electrolyzer when they are coupled with the storage, because then you can bring, the most value of them, because you have green hydrogen 24/7. That's definitely the idea for industrial use. So that's really how you take it from the state, still having this view of this is a market mechanism that we can put in place. Not a regulation, but still a form of clarification, I would say. And then from the usage, what will come first? So industrial needs. Mobility, I think we see less of that. So that's rather industrial needs for electrolyzer, and then little by little, interconnecting all this with the network, but most of all between countries.
Thanks very much. So clearly there is some market perspective, but there is also a need to take perhaps still a few steps before we are there with the help of public intervention also. So it's 10:30 sharp, but I want to nevertheless see one more time whether there are any questions from the audience before we close this panel. If that's not the case, and it doesn't seem to be the case, unless I overlook anyone, then perhaps if we can just have a few minutes to do one speed round. I will put sort of a question and ask every one of you to answer with 1 or 2 sentences if you can. And the question is the following. So recently, Hydrogen Europe, whom you all know, put out the request to the Commission that we should follow up the Grid Action Plan for Electricity with the Grid Action Plan for Hydrogen, which we are currently not planning. But if we did, what would be your number one action that should appear in such a grid action plan for hydrogen? So perhaps indeed, Ralf, we start with you.
Thanks. Yes, if we come to a real integrated grid planning process between the hydrogen and the electricity grid, and maybe together also with the natural gas grid, then I think it will be very important to see what will be the overall optimized solution that we could find. That means we have to how we have to handle the real sector coupling issues between this, and how especially hydrogen can support the electricity grid side with our potential that we have on our side.
Thanks very much. Charlotte?
Quite in line, actually. So that's about interlinked modeling, having the global approach with the logic behind of being at pace for the energy transition and at the best cost for the consumer. So we really need to integrate that part as well.
Piotr?
I think that this part of the grid action plan for molecules is a must. I think we cannot support different energy infrastructure separately, and I think it should go all along this energy system integration and let's say integrated planning together to choose the optimum solution for the grid development.
Also agree, and I would say that we have to add that as we have to start as soon as possible, somehow projects have to be selected to allocate the current existing capacity. PCI could be a possibility. PCI projects could be a possibility to be, they are the first ones to be connected to the network.
Yes, I also agree, and I think it's really needed to have this complementary approach between electricity, hydrogen, and methane. And probably we miss it today, and this would give a full picture. Also bringing on the flexibility part and how all this, the three systems can be integrated together. So definitely we need to have this integrated and complementary approach.
OECD has studied that an infrastructure can lead a positive economic growth beyond the baseline. And it's especially true if the infrastructure, what is in question, is new one. So therefore, I would underline that let's scale up the care nets of hydrogen of Europe as fast as possible, because €1 invested in that can attract 5 to 10 euros private capital on different value chains on top of that. So I would be incentivizing the care nets of Europe.
I'm in the Hydrogen Europe board, so of course I agree with what Hydrogen Europe said. Besides the joke, I like the idea of the care nets of Europe. I think it could be, you know, which is, you know, we've also been doing this with the European hydrogen backbone. So it's the idea of having, you know, kind of first core network of hydrogen, and also highlighting the different cost, which sometimes gets neglected. So in terms of, you know, how much capacity, how much energy you're moving around, so that we need both the electricity and the molecules to do this transition. And we should stop questioning this once and for all.
Thanks very much. So I think that's all the time we have today. So I would like to thank all our 7 panelists. I think it's been a very interesting discussion with many points of views. I noted perhaps 2 common themes, which is on the first hand optimism, which is I think what we would expect from you because you're our project promoters. So we hope that you will implement the projects soon on time and that you will overcome all the challenges which have I think also been raised and come out clearly in this discussion. And secondly, I think the one topic that all of you stressed was indeed the need to make our planning even more integrated than it is. I think that's in principle already the objective and the law, if I can say so, but perhaps in practice we realize that it's not that easy and we need to perhaps go one step further in actually getting there. So thanks very much to all our panelists, and please give a A big applause to them for having participated.
In Slovenskaya Elektrárnia, we believe that decarbonization of power generation is vital to energy transition and combating climate change. As the biggest electricity producer in Slovakia, we have a long history of construction, operation and maintenance of hydroelectric installations. With the energy transition in progress, intermittent renewable energy sources like wind and solar will add up in the Central and Eastern Europe. To address the grid stability challenge, Slovenskaya Elektrárnia has decided to build on its vast experience and combine hydroelectricity with an innovative approach to storing electricity. In north-central Slovakia, we are introducing SE Integrator, a project aimed to modernize the country's most important pumped storage power plant, Čierny Vár. With an installed capacity of over 735 megawatts, it has been helping to stabilize the Slovak power grid since 1982. SE Integrator is an innovative project aimed to increase the pumped storage plant's efficiency and regulation capacity, as well as hybridizing it with a battery system with a minimum of 70 megawatt installed capacity, which will be able to provide up to at least 105 megawatt hours of electricity. Combining the fast response time of the battery, backed by the bulk energy storage capacity of the power plant's water reservoir at the same site, it will require no additional grid capacity, saving it for renewables or for the industry shifting to electric, rather than fossil fuel-run technologies.
I am keen on having hybrid projects, pumped hydro, with batteries. If you attach 1-hour battery storage to pumped hydro using the same switchyard, you have a very valuable grid stability tool.
Avoiding carbon emissions, SE Integrator will bring new grid regulation capacity, needed during the transition from the soon-to-be decommissioned fossil fuel sources. This evolution of grid balancing will help to bring in more renewables, and to keep out the risk of blackouts. The project is in common interest of the countries neighboring with Slovakia, since the additional regulation capacity will be shared through the MORI and Picasso platforms. The environmental impact of SE Integrator is negligible, because the battery system would be located on site of the original pumped storage plant, which will also get a turbine upgrade. The project is a crucial contribution to the implementation of the Slovak Integrated National Economic and Climate Plan, and it plays an important role in the Fit for 55 and Repower EU strategy. On our way to reaching the climate goals, the existing power and network infrastructure will crave for cost-efficient and environmentally friendly answers to the challenge of decarbonization. Our answer is SE Integrator. Clean, smart, and flexible.
Europe is making its way towards a climate-neutral future. To achieve this goal, it will need to import 10 million tons of renewable hydrogen by 2030. More than 40% of this target could be reached thanks to production centers in North Africa, where solar and wind are abundant resources. But how will Europe and North Africa be connected? The solution is called South H2 Corridor, a 3,300-kilometer dedicated hydrogen pipeline linking North Africa, Italy, Austria, and Germany. It is developed by the 4 European transmission system operators for gas: SNAM, TAG GmbH, GCA, and Bayernets. All the individual TSO projects were included in the first list of projects of common interest under the revised 10E regulation, published by the European Commission on April 8, 2024. Being part of the European hydrogen backbone, the South H2 corridor plays a key role when it comes to establishing an interconnected and diversified hydrogen market. Significant CO2 savings will be achieved in all countries, thanks to the supply of large quantities of clean hydrogen to the main hard-to-abate demand clusters along the route. The South H2 corridor uses existing infrastructure for over 65% of the route. Repurposed natural gas pipelines are the most effective, competitive, and sustainable transport method. This ensures the effective supply of hydrogen at competitive prices. Thanks to a significant transport capacity, the South H2 corridor will give an important contribution to achieving European and national climate goals, as well as diversifying hydrogen import routes, ultimately ensuring security of supply.
Implementation of smart grid infrastructure is key for development of European energy market. The projects Econ and Danube in Grid focus on mass deployment of cutting-edge smart technology. This will enable to monitor and manage grids remotely, which means that the grid parameters can be flexibly adjusted and the failures can be managed efficiently. The projects focus on strengthening cooperation between distribution and transmission system operators, both on national and cross-border level. This will speed up modernization of our electricity grid and will enable high capacity for integration connection of renewable power sources. We are installing smart devices which will increase quality and security of supply, which means better reliability for our customers.
Aurora Line on voimajohtoprojekti, joka yhdistää Suomen ja Ruotsin sähköverkot toisiinsa. Sen pituus on yhteensä 380 kilometriä, josta Suomen puolella 200 kilometriä. Suomen puolella se alkaa Muhokselta, menee Keminmaan kautta Tornioon, jossa ylittää rajan, ja Ruotsin puolella se jatkuu siitä sitten Jokkmokkiin, ja siellä olemme Messaaren sähköasemalla. 152 kilometriä otetaan käyttöön jos nyt 24 syksyllä. Ja sitten se viimeinen osuus Keminmaalta sinne Ruotsin rajalle ja Ruotsin puolin niin valmistuu 25 vuoden lopussa. Siis totta kai tämä on valtava iso hanke, iso voimajohto, se on jaettu useampaan osaan Suomenkin puolella, mutta sitten suurin haaste tässä on ollut se, että täällä on hirveän paljon soita ja siellä on paljon pehmeikköjä ja rakentamista ei ole voitu tehdä kesällä ja syksymärillä. Suurin osa rakennustoista on jouduttu tekemään roudan aikaan eli talvipakkasilla. Ihanteellinen keli on sydäntalvella, kun päivä alkaa pidentyä. Että on pitkät päivät tehdä töitä, mutta maa on tarpeeksi jäässä, että päästään kulkemaan eikä aiheuteta maastovahinkoja. Ruotsalaisten kanssa meillä on ollut tiivistä yhteistyötä heti alusta lähtien. YVA-vaiheessa varsinkin soviteltiin aikatauluja ja niitä, miten toimitaan ja miten edetään. Ja sitten nyt rakentamisen vaiheessa meillä on kummallakin puolella omat projektit, mutta sitten meidän täytyy totta kai sovittaa se Tornionjoen ylitys, että saadaan aikataulutettua sillä tavalla, että kaikki menee hyvin.
Aux origines, il y a un lien, une histoire, un héritage commun entre les deux territoires. Le projet Celtic Interconnector s'inscrit dans cette culture celtique qui aujourd'hui encore unit l'Irlande à la France. Responsable et solidaire, Celtic Interconnector reliera les deux réseaux électriques et plus largement connectera l'Irlande à l'Europe. 575 km de câbles qui faciliteront le développement des énergies renouvelables et participeront à la construction d'un avenir énergétique faible en carbone. 700 MW qui contribueront à une électricité plus sûre, plus durable et plus avantageuse pour les deux pays. Unis pour accompagner la transition énergétique, RTE et Airgrid se sont engagés à minimiser l'impact sociétal et environnemental des infrastructures en menant en amont études techniques et concertations locales. Aujourd'hui et jusqu'en 2027, des deux côtés de la mer Celtique, des femmes et des hommes s'activent à déployer l'infrastructure d'un projet reconnu d'intérêt commun par l'Union européenne. Celtic Interconnector, la liaison électrique entre la France et l'Irlande.
Si chiama Elmed. È il ponte energetico tra Italia e Tunisia che Terna e Steg stanno progettando per collegare due grandi sistemi elettrici, quelli di Europa e Nord Africa. L'interconnessione energetica e il collegamento delle fonti rinnovabili alla rete sono fondamentali per un sistema elettrico euro-mediterraneo integrato, sicuro e sempre più sostenibile. Elmed è la prima interconnessione in corrente continua tra i due continenti. Un'opera da 600 MW di potenza e 220 km di lunghezza che sarà realizzata tra la stazione elettrica siciliana di Partanna a Trapani e quella di Mlabi in Tunisia. L'attenzione al territorio e alla sostenibilità è un punto fermo dell'infrastruttura, che coniuga soluzioni tecniche all'avanguardia e minimo impatto ambientale. La tratta sottomarina dell'opera prevede la posa a circa 800 metri di profondità di un cavo lungo 200 km che raggiungerà la costa tunisina, nella penisola di Capo Bon, attraversando il canale di Sicilia. Un'opera di interesse europeo che nel 2022 ha ottenuto un finanziamento di 307 milioni di euro dal programma Connecting Europe Facility. Per la prima volta i fondi comunitari per la realizzazione sono stati assegnati, oltre a uno Stato membro dell'Unione Europea, anche a uno Stato terzo. Un progetto concreto che si inserisce nell'ambito degli obiettivi internazionali per una transizione energetica e digitale che sia anche equa, inclusiva e responsabile.
Europe has great challenges ahead. Accelerating decarbonisation and moving towards energy sovereignty by 2030. This is what the European Repower EU plan establishes, and this is how the different countries are working together. To this end, renewable hydrogen is the great ally, clean and produced domestically. The development of a European hydrogen backbone network with corridors linking supply from producer countries to demand centres will be essential. H2Med will be the first EU renewable hydrogen corridor capable of delivering 2 million tonnes of renewable hydrogen, which accounts for 10% of the projected hydrogen demand by 2030. Driven by the governments of Spain, Portugal, France, Germany, and the European Commission, and promoted by the TSOs of the countries, it was submitted to the European Union's Projects of Common Interest application on the 15th of December 2022. H2Med is made up of two interconnections, one between Celórico da Beira in Portugal and Zamora in Spain, and an underwater hydrogen pipeline between Barcelona in Spain and Marseille in France. It will play a pivotal role in connecting the production capacity in the Iberian Peninsula with demand centres in countries like Germany. With this purpose, the national network projects, also presented as PCIs and part of the corridor as a whole, are progressing in parallel. Developing a hydrogen economy will have significant benefits for Europe. Socio-economic, such as industrial development, innovation or investment attraction. Environmental, such as reducing emissions or improving air quality. And social, because it will help a just transition, employment promotion and the development of local economies. There are many challenges, and using the public-private partnership model, we're taking steps to reach the targets set by Europe. It is renewable and can be applied in all sectors, including those with difficult decarbonisation solutions, such as intensive industry and heavy transport. It is renewable hydrogen. And with projects such as H2Med, in Europe it is already a reality. Hydrogen is Europe. Hydrogen is now.
In a world transitioning to renewables and electrification of mobility and heating,
So, everybody ready? We're ready to go? Good morning to everyone. We will be starting shortly. Now suddenly there is a silence in the room, but I hope this is not prejudging the very nice discussion that we're going to have. Good morning again, and welcome to our panel, Pact for Engagement, a year in review, and the path ahead. My name is Alejandro Urzurrun. I am the head of unit for the Just Transition, Consumers and Local Initiatives in the Directorate General of Energy of the European Commission, so I work very closely with Joachim, whom you know very well. Probably you know me a little bit less. And I am delighted to be the moderator of this panel, which is going to start right now. I'm sure you will be interested in the discussion, so I will just make a very short introduction to frame the discussions of our panel, and then I will immediately introduce our panelists, and we will go on straight to the discussions. So, first of all, always important to take a little bit of perspective. Where do we come from? You know that in the last year's PCI Energy Days, the Commission adopted something very important, which is the EU Action Plan for Grids. And this EU Action Plan for Grids outlined 14 actions to accelerate grid modernization and deployment. One of these actions, very important now, was Action 12, Pact for Engagement, which was launched last year, and it is an essential tool to accelerate the deployment of grids, and that is important because the deployment in grids is fundamental for the implementation and acceleration of the energy transition. So, that's the background. Now, what do we have in this pact? The actions of the Pact for Engagement are voluntary commitments of stakeholders. The Pact and the organizations who sign up to the Pact specifically aim to ensure early, regular, and meaningful stakeholder engagement in grid development. And that in order to address potential public concerns and ensure the highest standards in stakeholder engagement. Engagement being, of course, the key word for today's panel. And why engagement is important? Engagement, acceptance, they are crucial for an efficient setup of energy networks, which enables the energy transition. Engagement, energy transition. That's what we're working on here today. That's what we'll be discussing in the next hours. Let's look a little bit now at the political context. I'm sure many, if not all of you, have read the mission letter that President von der Leyen sent or addressed to Commissioner-designate Dan Jørgensen, where he asked the Commissioner-designate to develop a citizens' energy package that would increase participation of citizens in the energy transition and strengthen the social dimension of the energy union. And I am sure you will hear more about that very soon, because definitely you know that the Commissioner-designates are now undergoing their hearings in the European Parliament, and actually Commissioner-designate Jørgensen is going to hold his hearing at 2:30 today. Furthermore, beyond the citizens' energy package, grids should be upgraded and expanded to support rapid electrification while remunerating those citizens that take part in the energy transition. So, action means action, things need to be done when we have something which is called action. So that's why the Commission has set up a dedicated stakeholder group to discuss and advance the Pact for Engagement, which is the subject of our panel today. Several meetings have already taken place. Stakeholders, by the way, include member states of the European Union, transmission and distribution system operators, industry and public stakeholders associations, including, of course, NGOs and industry representatives and others. With these stakeholders, the Commission has drafted and agreed guiding principles for early public engagement for the development of energy infrastructure projects. These very important principles outline common perspectives among the signatories of the Pact for Engagement. Furthermore, they serve as a common ground of understanding of public engagement in the development of infrastructure projects, and they are complemented, and this is always very useful, by best practice examples which have been shared by contributing stakeholders. Who are these principles addressed to? For whom they are? The principles address stakeholders, such as private and public developers of energy infrastructure projects, as well as national regulatory and permitting authorities who are involved in the infrastructure development on the ground. I'm very happy, on behalf of the Directorate General of Energy of the European Commission, to endorse these principles with you today, and most importantly, I'm very happy to have a discussion about those principles. With that, you will be glad to hear that you will stop hearing me, and I will be now go into the introduction of the very good panelists that we have today. Let me introduce them. Chiara Martinelli, who is the Director of Climate Action Network Europe. Thanks for being there. Welcome as well to Andrzej Ceglarz, Director for Energy Systems in Renewable Grid Initiative. Andrzej, welcome. Welcome as well to Björn Santana Arvidsson, Deputy Managing Director for Hydrogen and Vice Managing Director in Nordion Energy AB. So, hi there. Welcome as well to Henrik Boysen, who is the Head of Unit for Grid Planning and Sector Coupling in Energinet. So, hi there. And of course, welcome as well to Julia Gross, who is the Policy Advisor in the Department for Strategic Energy Policy in the Federal Ministry for Climate Action, Environment, Energy, Mobility, Innovation and Technology of Austria. So thanks a lot, Julia, for being there. So, and now we will start talking, and I would like to start with a general question to all our panelists. Because when we do things, it is important that we are clear about what we do, why we do it, and how we do it. So I would like to start by asking a question to all of you on how do you specifically address and engage the public in your work? How you do it? And why do you do it? Why would you encourage others to support the Pact of Enlargement? And why do you actually think this is a good idea for your organization? And then what? What do you think about the guiding principles for early public engagement? What are your views on that? So maybe we start with Christina. Yes, of course. And I will sit here with all of you. Perfect.
Okay, can you hear me? Yes. Good morning. I'm Chiara, not Cristina.
Sorry, my apologies.
Sorry, I'm very proud of my name.
And I apologize sincerely.
No problem. And good morning, everyone. Thank you also for the invitation. So how do we do public engagement in our work? I represent a network of civil society organizations, more than 200 organizations across the European continent. So public engagement is our DNA, I would say. Mm-hmm. So the main two words that describe our way of doing public engagement, I would say, is consultation and co-creation, meaning like sharing intelligence, sharing information, also providing capacity building, but also sharing good practices and experiences on the ground. And with all of that, build viable pathways on the way forward. So that's why we think the Pact of Engagement is also fitting to who we are. And we do believe the Pact of Engagement is a vital first step in building public acceptance in electricity infrastructure, but also a tool, the Pact as a tool for democratizing the energy system planning. That is also very much at the core of our mission. As Can Europe, also we do work with some modeling for the energy transition, the so-called Paris Agreement compatible scenario, that actually shows that the capacity will need to triple by 2040 in transmission only. So with all that said, we do believe that the expansion, because we speak about expansion, needs to start from the very first step in the best way possible. And in this sense, we do work with communities across the member states. We do believe that if this first step is not done right, basically the experience is telling us the way people will receive those cables is like something coming from the sky. They don't understand why and what. So in this sense, the Pact for Engagement is a very first good start. And then maybe to add also that it needs to be in a way a public engagement, not just as box ticking, right? But also it's about capacity building for communities, but also a way to show, and that is why we are all here together, that is not only public engagement, public pact for engagement for communities on the ground, but is a pact for engagement for all the different actors that are needed to accelerate the energy transition.
Thanks a lot, Chiara. And again, my apologies for getting your name wrong. I was very happy to... Thanks a lot for the very good points that you made. There was one which I particularly, among the many good points that you made, one which is very important, which is the element of democracy. When we read the political program of President von der Leyen for the next mandate, she said, prosperity, she said security, and she said democracy. And she has emphasized how important it is that citizens are effectively involved in the policy making and implementation. So thanks a lot for making that point. Maybe Julia, we move on to you. Now I am super stressed that I get the names wrong. So if I get the name wrong again, please.
Yes. So thanks a lot for inviting me. I'm working at the Federal Ministry. So there, of course, the traditional, most common tool still of engaging the public is publishing a draft and then giving the public the opportunity for written comments. And I do think that is still a very important tool to have a reality check, a quality check, and also balance somehow the concerns of different interest groups. But for sure, for this transition, we need to do more than publishing just drafts or comments. So to convey, as you said, the message, why do we need certain infrastructures? Why is the landscape in Austria, that's a very important point, changing because of big electricity cables, of windmills, etc. And there's also a lot of skepticism about that and protests in some regions in Austria. So this is very important to address. And I think it's especially important on the local level, so with projects, organizers, to address that. And we also have some good examples already where permitting procedures really were shortened because upfront there were working groups trying to solve the best route and addressing the concerns. But of course, it's also the responsibility of ministries and administrative levels to do more. And we are trying, or what we are doing at my DG Energy for Climate and Climate at my ministry is to have more workshops during the conceptual phase already when designing a law or a new strategy. So that's, for us, of course, it's important to have exchanges with different stakeholder groups to learn about their solutions, their proposal, but it is also very important to explain in more detail why this strategy is coming or this law is coming, what is the intention behind it. For example, we did that now for, because we're after the gas market package, to have the regulation of decommissioning gas pipelines, and there's of course a lot of skepticism with different stakeholder groups, but we not overall managed already to convey the message that this is really important measure of cost effectiveness, of bringing down the cost of all that system, and yeah, I think through that we can achieve quite a lot. And another measure that I just want to mention is we also have a citizen council on climate, so where a diverse group of citizens wrote together recommendations for climate action, presented a policy, and there was just a very interesting process to see how this really diverse group also came to a proposal of actions that are more broadly accepted.
Absolutely. Thank you very much. I also like very much, among the many points that you made, is that you have to have an early involvement for the engagement to be meaningful. And of course, as a representative of a public authority, it's very important to see how you organize that. Public authorities have an important role. And maybe during the discussion, it would be good to see how you work also with local authorities, with municipalities, and and other local structures, because they have a really important role there as well. Thanks. So, Andrei, what do you think about the what, how, and why?
Yes, thank you very much for the invitation. So, from our perspective as RGI, we do not develop the projects on the ground. Therefore, we do not engage the public, but we put a lot of value, and we believe that it brings additional benefits to do the public engagement on stakeholder engagement in a very meaningful way. And I think this is also reflected and illustrated in the document that you mentioned about on guiding principles on public engagement, because many of the practices included in this document are actually practices of our members. So actually it means that what we are working on is also valued and worth sharing with the others. And yesterday we had a RGI awards ceremony here with one specific category dedicated to stakeholder engagement and communication, which also shows that we put a lot of value how to engagement with stakeholders. But I wanted to follow up to your different question about this document on the principles. How do we see them? So first of all, that building these principles and coming up with the document was a very good example of engagement, how to bring different stakeholders on board and how to create such documents. So also congratulations to the Commission for carrying out such engaging process. And all the principles included there are just good. There's nothing like to comment also, because the way how the process was done. But one point that Chiara and Julia mentioned also about the regulators, and one part of this document that is about the guiding principles, you didn't mention about it, but there is a subchapter dedicated to the perspectives of expenditures and the recognition or the regulatory recognition of stakeholder engagement, which is important to have, because without recognition of the costs needed to meaningful engage public, to engage stakeholders, those measures will not progress. And that's one of the conclusions of the infrastructure forum in Copenhagen, that ACER and the NRAs should explore opportunities. What are the options to think about the regulatory recognition? And this is something I think that it's a proper place to announce it, that together with Acer and the Commission, we started a work to think what could be these opportunities of regulatory recognition of stakeholder engagement, and until end of the year we are going to distribute a questionnaire to a lot of project promoters, to NRAs, to other stakeholders, to collect the information, what are the legal and the regulatory gaps in different member states, how to address them, and what could be the potential solutions to deal with that.
Absolutely.
Thank you.
Thanks a lot, and say that I'm sure everybody took well note of. And indeed, we do need a perspective, because we're not talking about short-term things, we're talking about things, investments, infrastructures which have a long-term perspective. So when we talk about engagement, for it to be meaningful, we need to look at the long-term perspective. Björn, what do you think about all this?
First of all, I'm very happy to see so many people in the audience.
I am too.
Yes, because this is
really
super
great.
important area. So how many believe that this is actually core business? Raise your hand. Okay, we're getting there. Because without people, there will be no engagement. And if we don't have business with people, we don't have the community with people, then we don't create any value. So for me, this is very close to my heart, that engagement with the public, with the people living in the area, with the ones working in the industry, living in the municipalities, etc. That's really the key. This is the main driver for me. And why? It's also just like you said, Alessandro, that this is long-term. So with the people that we meet, we have to have a long-term relationship. I know from our core business, we're an energy infrastructure company, so we're the gas TSO of Sweden. Our best sort of defenders or surveillance system of our network is the people, the farmers and the people taking care of the woods around our infrastructure. We have like a partnership and a close relationship that we have to endure for the lifetime of the infrastructure. So it really starts with the public. And how do we do it? We launched together with Gasgrid Finland, so Nordion Energy and Gasgrid Finland, the Nordic Hydrogen route in April 2022. And we didn't start immediately to engage with the public, with the municipalities, but very soon after. And then we have made like a road show to meet every single municipality that would be affected. We've been talking with all the regional bodies, we've talked with the people in the area, really talking about and having a dialogue, how can this bring value to you? Because if it's something that feels that it's concerned them, then you will have an engagement. Absolutely. And the word I don't like is acceptance. Quite often you talk about social acceptance. It's something you just have to accept. You don't like it, you just have to accept it. But if you manage to create the engagement, this is really the key driver. So for a connecting project, we did a public consultation. So we met all the inhabitants of the small villages. So it's not a very densely populated area up north. But despite having so much space, there's very little room for infrastructure, because in natural areas, there's defense areas, there's a lot of different values that you need to handle. But it was really a fantastic engagement from the people. They were really sharing their frustration, their fear, their hope, their curiosity, and their full support. And I think in overall, the majority of the response has been recommendations. What to do even better. And this is fantastic value creation. So I fully support the Pact of Engagement. I think we don't have to fit in the box, because it's really a very, very well-fitting box. It makes perfect sense, and it's all about change management, and we're in for the change. Thank you.
Absolutely, thanks a lot, Björn. Really inspiring. I think we have all noted your very good motto: without people, there is no engagement, and sometimes we should put people first. So people is the most important. And as you say, it has many good benefits, starting with the democracy that we were talking about, but also it has operational benefits, because people on the ground, they know pros and cons, and if you are smart, you take those pros and cons, and your system works better because you design it better. So thanks a lot, Björn, for that. And now, Henrik, You're the last but not least, how would you say, last but not least. Yeah. What do you think about all this?
Yeah, first of all, thank you for this invitation. Of course, I think it's very important to engage with the public, because if we do not do that, then we cannot succeed with the task we have. And actually, we have a very important task, and we are very busy in order to succeed in this climate change task we are having. And therefore, we need to plan very good, but we can do the best plans. But if we do not have the public and the public acceptance, then we will not be able to succeed. And we all know the examples of people who do not want infrastructure in their backyard. And therefore, we need to go out and meet with people. But actually, what we see in Denmark is also that they see energy infrastructure as a sign of progress, and they do want the energy infrastructure. And also, when that is the case, we need to engage with people, because if we just say, okay, you want more energy infrastructure, so you'll be in top of what we are doing, then we might not do it as good as we could do. Mm-hmm. So it's also about optimizing our investments in order to do as much as we can, as fast as we can with the money we have and the resources we have. So that there are many perspectives on this. So public engagement is in all of the stages of the planning. We have to do it before. In Denmark, we have the special case that we have an enormous energy, or at least an area that could be used for an energy resource in the North Sea, not for Danish consumption, but for European consumption. And if we do not get the acceptance from the citizens affected, then we might not be able to harness that potential. Absolutely. So it's extremely important that everybody sees the potential and they will accept it. Maybe also love it, but at least accept it. So that's one of the whys. Yeah. But also we also need public engagement in the planning process, because we need the information from the municipalities, from the developers. Mm-hmm. Where do they want to put their energy infrastructure, and how can we, based on that information, plan in the most efficient and most effective way? So I think that's basically the how, now the why, and then the how. I would say we are not there yet. We haven't done everything in the most successful manner, but we are in a progress. And one thing I think is very important is, and something that we are developing, is working closer with the municipalities, the local communities, because I think what we experience in the Danish context is that they are key in order to be able to build out the infrastructure and get the acceptance that is needed.
Absolutely. Yeah. Thanks a lot, Henrik. Those were very good points. Again, you made a point of optimization, which was made before, so that through engagement you optimize your decisions on investment, not only for you, but also for society. So you optimize the social result. And I like the point on municipalities very much. Municipalities are small, they don't have a lot of resources, and they have to tackle a lot of things at the same time. So they really have an overview of all, not only energy issues, environmental issues, but other social issues, etc. So working with them really gives the broader picture. Mm-hmm. Okay, thank you very much. So I think you enlightened us a lot about the how, the why, and the what. But now let's tackle a couple of specific questions. So, Chiara, we're talking here about engagement by citizens. We are here in a European context. So many stakeholders, many member states, many ways of achieving public engagement. Do we have a common ground? So are we all talking about the same, are we all talking in the same language, let's say, or referring to the same things when we talk about public engagement? Or do we still need to develop a common ground when we're thinking about implementing our principles? Do you think there is work to be done there?
Yes. I mean, I do think we have some common ground, especially in this room, and I think this is already encouraging. But we do need to build a European common ground at different levels of the action that is needed. And I think that also we need to, I mean, I'm very happy to hear like all the different stakeholders here a little bit on the same page on this regard, but let's be also very honest, like this is not going to be easy, right? There are also some barriers, there are some obstacles, there is some resistance, so I think we need to go a little bit a step further, and I do hope that this pact of engagement and the guiding principles could help on that regard to build this common ground. So I think for Can Europe, there are three main elements that will make this common ground possible. The first one is the integration of civil society in public engagement. And when I say that, it's not just because it's a nice thing or a nice add-on or a decoration of your plan on the energy transition, but it's because it's an element that is making the transition lasting and possible. So, and in that sense, I wanted to bring two examples. The first one, I think, is also a little bit a reflection on the political context and the societal context we are living. I mean, if we don't involve civil society and in public engagement in this process, we risk a huge backlash. And we do see that backlash, unfortunately, already like happening across the different member states. So that involvement of civil society is a way to counter that. And why we want to counter that is because all this backlash is basically delaying a transition, and we cannot afford this delay if we want to be true in addressing the climate emergency. So, I mean, maybe it's a little bit of a dry comment, but it's more on the strategic level of why civil society engagement is needed. And the second reason why civil society engagement needs to be at the core is, again, another strategic element. I mean, if you go at the local level, where local authorities work, often these NGOs, especially the ones that work on nature, are trusted by people, are trusted by farmers and by communities in their region. So we need to use those NGOs and those civil society leaders as the ones explaining all the why, as the communicators, like on the why and the reasons of what is going to happen at local, and the impact that this is having at local, national, and global level. The second point, why I mean on the common ground, I think it's important, and here is also a little bit a message maybe to the European Commission. I mean, yes, we are all very happy that we have now this guiding principle, but we do believe that there is a role for the European Commission now to tracking how these guiding principles are being implemented and to facilitate much more an exchange of good practices at the different level we are talking about. I see that the time is running, so my third point is also, I mean, when it comes to inclusion of the different part of society in the public engagement, I think we do often forget about the most marginalized and vulnerables. So I think this is also an important point that especially the ones here in the room that are really like working on the planning of the energy infrastructures and needs and all of that, that we factor in such an involvement also of those most vulnerable and most marginalized parts of society.
Thanks a lot, Chiara. Absolutely important point. Strategic role of civil society. So it's not checking boxes. They have a role to play, and without that engagement, we will not achieve our transition objectives. Role for the Commission, tracking, facilitating, and also very important because we are talking about a just transition. I'm actually responsible in the European Commission for the just transition. No one must be left behind, and we have to take into account vulnerable groups. That's really, really very important. Thanks a lot. And Andrei, now, looking ahead, I am told you were one of the most earlier proponents of the Pact for Engagement. We have already made some progress, but what next? What should we be doing next?
So, so basically, well, RGI, since was established 15 years ago, has been leading or putting stakeholder engagement into the center, so no wonder that we were pushing to have it also on the paper. But there are 2 points related to what are the next steps of a pact for engagement, or let's say processes around it. So first one is related to the implementation. So it's like with the projects, infrastructure projects. You have the plan, you have it on the paper, and then you focus on the implementation. Today, after this discussion, there will be a ceremony of putting signatures of other stakeholders into the Pact for Engagement. But the question is what to do that it does not stop of only putting a signature on the pact. So how to make sure that it does not stay only on the paper, but all these stakeholders indeed remain committed to follow the principles. And I would say not only the principles, because, and I fully agree with Chiara, I also wanted to mention about it that what would be needed is kind of tracking or maybe even a reporting mechanism. In Pact for Engagement, there are 5 different points addressing different stakeholders. And this is not only on the project promoters or project developers to be involved, but also to public authorities and to regulators. So I think that the next step is to think on the implementation, to make it effective, to keep the momentum of the discussion, because it also took years to actually have at such event very serious and interesting discussion about stakeholder engagement, to keep the commitment. But with commitment, the another thing that comes are resources. All these actors or stakeholders that would be responsible for the implementation of the points included in the Pact for Engagement need to ensure that there will be adequate resources dedicated for dealing with these topics.
Absolutely. Thanks a lot, Andrei. So signing is very good, and we will have a ceremony now, but then we need to follow up and check that we're doing the things, and in order to do things, we need resources. That's really clearly made. Thanks. A point very clearly made. Thanks a lot. So, Björn, gas and electricity grids, we have quite some experience when it comes to engagement, but maybe hydrogen is a little bit of a newer area. So what is your take? What have we learned from the past? Or are there any specific things which come to your mind when we talk about hydrogen grids?
Yes, indeed, Alessandro. I think the first point is, at least in Sweden, everyone has a very high trust in electricity. Everyone has a relationship with electricity. But when it comes to gas infrastructure, there's on the west coast and the southern part of Sweden, yes, but for the rest of the country, there's no relationship with gas infrastructure. It's something new. And then you add on to that hydrogen, then it gets quite difficult to relate to. And then it takes time to mature. So it's so important to start early, to have the engagement, to make sure that you sort of get on common ground and you have the relationship. And how do you do that? It's to build trust. It's really to be there long-term, transparent, reliable. So having the regular feedback and the dialogue with them to build the trust that this is something for the long term, it's something to serve the society and the industry. And that's the only way forward. Yeah. But we are sort of in that process now, and we have still a long way to go. But I think we have a very good start.
Absolutely, I agree. I agree with you. So we have an opportunity there and building on learnings in the past. And it's also very interesting how you put it, like even within the same country, geographic, I mean, the take can be different from one place to the other. Thanks a lot. And now, Henrik, I read that you organized a democratic festival, Folkemøtet, so I probably didn't pronounce it correctly, but you did that in Bornholm in June 2024 when you engaged with a lot of public stakeholders. You signed the Pact for Engagement there. Now, high-level policy making, organization on the ground. We hope to bring them together. We're all in it together, but perhaps there is still a gap. If you agree with that, how we could make the gap disappear?
Yeah, I agree very much with what you say. And yes, there is a gap. And when you look at the figures of how much more solar panels we'll have in Denmark, how much more overhead lines we will have in Denmark, it is massive. So there is a very big gap. And if we do not fill out that gap with trust and understanding and acceptance, then we might not be able to succeed in, as I said before, in actually doing what is our task to do. So, and we are starting to fill out the gap and go in dialogue with NGOs and the public in broad to be able to bridge the gap and make sure that people accept and understand what we're doing. And when we see at the public discussion in Denmark, at the debate today, we see that at least I see some signs that the support for the green transition is not as big now as it was some years ago. And I think it has very much to do with people actually seeing the solar panel, actually seeing the overhead lines above their heads. So and therefore we need to do more, and we need to do it more structured, and that's what we are going into, both with the municipalities and the green NGOs and the public in broad.
Absolutely.
Yeah.
Thanks a lot, Henrik. And indeed, you pointed out again at municipalities and how they are important. Maybe, but you wanted to say something else, please.
But just a point that this is not for free. It takes money to do this work. So I think you ask about the common ground, and I think it's important also from the Commission to signal and send the message that this is something that needs to be addressed, and there needs to be the road open for us investing in public engagement.
Absolutely. Thanks a million. Thank you. And that gives me a good cue to ask Julie a question, because you work, you have the Austrian Integrated Network Development Plan, ONAP, and maybe you have there good examples on how you have integrated in this plan a framework for public engagement. So we would be very happy to hear about your experience. And also, because it looks like I give it a lot of importance, if you have any thoughts on the involvement of municipalities and local governments, that would also be very important.
Yeah, thank you. Yes, so we published this integrated network grid infrastructure plan, which shows the long-term infrastructure needs of the electricity and gas, and especially hydrogen sector in Austria, for being on a path to reach climate neutrality. Sorry. And it was so we published it in April, and it was the first time that we as a ministry took really an active role in energy planning. And we did that not to replace the plans of the TSOs, but to really increase the public view and the acceptance of these infrastructure needs, and show that there are in the overall interest these needs. And we did that by, of course, working together closely with the TSOs, but also with scientific institutions, to have more of a kind of neutral external partner to assess these infrastructure needs as well. Yes. And the goal was also to solve, so we have some energy line permitting procedures which really took a long time. And they're always the same kind of questions. Isn't there an alternative? Do we really need this infrastructure? Where is the best route? And we try to address some of these conflicts already beforehand with this overall political plan. By, as I said, having the scientific institution who said, no, these capacity increases between these 2 points are needed to integrate more renewables, to have an integrated European market, energy security, etc. And also we did a strategic environmental assessment of the plan, and during that process of creating this assessment, we involved a lot of environmental NGOs and also representatives of the federal states. Not that much municipalities, I have to say. And to also address this question, where is the most suitable place in environmental reasons, and also due to proximity to municipalities, where new energy infrastructure can be built. Yeah, and on the question of acting more locally, so in Austria we have 9 federal states, and they are responsible for the spatial energy planning, and are the ones who are creating the laws, etc. So there was also a lot of skepticism and criticism at the beginning why the ministry is now taking more of this active role. And usually if we have engagements with the federal states, they have to come to Vienna, so they have from the western parts, they have quite a long of traveling time. So we turned that around, and we have made kind of a tour after publishing the plan with this draft to all of the 9 federal states, and to have local workshops there with the state representatives, but also with local energy employees and environmental NGOs and industry representatives. And that really helped in the working relationship with the states to address also some of their concerns, and also for us it was really helpful to learn about the different challenges and approaches. So, and we also, during this whole process, then try to be as transparent as possible by having a really detailed discussion of the methodology and assumptions taken. So, yeah.
Absolutely. Thanks a lot. Really, really very good feedback on how you organize in Austria. And of course, municipalities are important, but also federal governments are important. Federal states, in the case of Austria, are important in the engagement as well. So thanks a lot, Julia, for that. Now, we have a challenge, which is we have 9 seconds left, I think, but I wouldn't like to finish our discussion without asking all of you a very quick question, for which I would like to ask you to be very short. So let's project already ourselves 1 year ahead, and we think already about the PCI Days of 2025. Joachim and the team are already thinking about the 2025 experience. Now, if we have the same panel in 1 year, what would you like in 1 sentence to say, okay, during the last year, this happened and this was good? I have noted already a couple of wishes for the Commission. Like one is in the monitoring, implementation rather than monitoring, and also in reminding the political impulse that it is not just words, this needs to be followed up by action. So those things I have already noted, but what would you like to be happy about in 1 year? We start with you, Chiara.
Yes, trying in 1 sentence. I think I would like to see in this panel more some sharing of good practices of why public engagement has been crucial to deliver. And I would like to see the conversation moving from why we need public engagement to actually a discussion on if we have really public engagement, we can discuss more about the ultimate goal, that is a more just procedure, but that is also a more fair distribution.
Absolutely. Excellent point. Julia?
Yeah, I think I completely agree. I would also add to have some concrete measure out of this process. So, for example, to have a platform exchange for good practices, or to have concrete tools that also more local organizations who might not join here, etc., can really apply in their daily work.
Absolutely. So we really want to be talking about action when we meet in 1 year time. Thanks a lot to Julia. Andrei?
Yeah, so I agree, and I think that maybe seeing more signatories of the Pact for Engagement next year, but something else, I think those best practices, exchanges or illustration is a good one, but I think that all knowledge that we will develop about the engagement should be connected to other processes that are taking place, that are also included in Grid Action Plan, because they will not be easy when it comes to the planning of the system, when it comes to the discussion on the anticipatory investments, when it comes to the permitting provisions in regard to renewable acceleration areas, to the grid acceleration areas. So I think that engagement should also be put in other context about the actions that need to take place to accelerate with the energy transition.
Excellent point. Well, a broader perspective on citizens' engagement, not just on a specific things. Björn?
1 sentence.
Good.
A long queue outside of the room.
Very good. That's what we cannot complain about this crowd, but we want a bigger crowd next year. Very good, very good. Thanks a lot. And Henrik?
Two things. First, I hope that we can see visible progress in bridging the gap between what we need to do and what the public wants or accepts us to do. And then second, we have some municipalities complaining that we are not building out as fast as we could for their energy needs. And 1 year ahead from now, I hope that we won't have that kind of meetings.
Okay, thanks a lot. Thank you very much. So this would wrap up. So today's panel was about engagement, and I think that we cannot complain. Our 5 panelists really were engaged. So the first thing I would like to ask is a round of applause to our panelists. This was really so interesting. So thank you very much, and thanks a lot to all of you. Now, the second thing I have to do is to announce that we are actually going to have a signature ceremony or signature act where I will invite the signatories to come up to the stage and to actually sign the pact. It will take us 1 minute, so we will leave the stage and we will make during 1 minute some arrangement to have the pact actually here. And then I will invite the signatories to come up. As it has been already established, I am not so good at remembering names, so I will not call people name by name. I will ask everyone to come to the stage and sign. And after the signing, we should all stay here and take a nice family picture. So that takes 1 minute. Please don't go. We'll let our colleagues do the necessary arrangements, and then we have the ceremony. And again, thanks a lot to all of you. Thank you. It was really great. Sorry. Thanks a lot. Thank you. So, dear colleagues, as announced, now I am really very happy to announce the start of the ceremony for the signature of the Pact for Engagement. The proceedings are rather easy, I should say. I would invite all signatories to proceed in no particular order to the part of the stage where we have the two copies of the pact for signature. You will get a marker there to make your signature in either of the two documents. And after you have signed, I would like to invite you to remain on stage, and then we will take a picture, a family picture of all the signatories. So please go ahead. You have the privilege of being the first. Yes, you might use those stairs as well. Thank you very much. Thanks a lot. Thank you. We have two, so you can share one or the other. Thanks a lot. Thank you.
It's not only for engagement, but of engagement. So
Absolutely.
for more people to sign the process.
Absolutely. Absolutely. So everybody should implement that.
Not only implement, to join
the process. Very good. Very good. I do that. Absolutely. I'm very happy to see a lot of people here. So, sorry.
Mein Vater hat am 24. November meine Schwester heiratet.
Go ahead. I see you are already well prepared for the family picture here. Absolutely. Absolutely. The pact needs visibility, let's say like that. Absolutely. That was really well prepared. checking here that everybody's signing. Yeah? Thanks a lot. Thank you. Oh, I can give this back to you. Thank you. Thank you very much. Thank you. Thanks a lot. Is there has everybody signed? So I would like to invite you all to you're taking the picture from you want
we can start the group picture from the wall, and we're gonna move that on the
Yes,
side.
I'm going to ask 2 volunteers to carry the actual pact. Okay. So of course, I like that. Very good. Now, I need 2 volunteers to actually. This is not very heavy. So who would like to take a copy?
I would like to take that one because I'm signed here.
You take this one.
Okay.
Who else would like? Very good. So, please.
Which one, Italy?
Absolutely.
Yes.
Absolutely.
I take the second one on the other side because
I know, absolutely. No, but in the center. So in the center, you must be in the center. You must be in the center. Very good. This is a reminder. So we have here the signatories. We have here the signatories of the pact, and that is great. But everybody here is invited to be part of the process. You all have to be engaged. You are all invited to be part of the process. And now I will move on, and I will let the photo take place.
Maybe you need to repeat because you were silent.
I was silent. Okay, so before we take the photo, one last message from our side, from the side of the Commission. It's such a nice family picture. We want this family picture to be as big as possible. So all of you who haven't yet been involved in the process, you are invited to be part of the process. So we count on you for the next steps. Thank you very much. And now let's smile for the picture.
please, everyone, the camera, can you move behind?
Okay, this is not as easy as we thought. And if we have anyone else who would like to volunteer to take the actual text of the pact, you can share it and we can take different pictures as well.
Just one sec. I check the setting. Okay, you can look my camera, everyone, you can smile. Please up a little bit just this one. To be seen more there. Okay, big smile. That's perfect.
Thanks a lot to everyone. Thank you. Thanks a lot. So now... encantado. Muchísimas gracias. Pero sí que nos conocemos. Hemos visto algo. Nos hemos visto alguna vez. Sí, sí, sí. Encantado.
distribution and transmission grids cope with the rise in power flows and the lack of flexibility of reactive power. Recognizing the urgency, partners from Austria, Croatia, and Slovenia decided to join forces and tackle these challenges under the Green Switch project. The Green Switch project partners will modernize and digitalize the distribution and transmission energy systems. In transmission grids, new technologies, including power flow prediction and control systems, will be deployed. Dynamic thermal rating will be upgraded, and new components will be integrated into the supervisory control and energy management system. In the distribution grids, substations will be automated, an advanced distribution management system will be upgraded, and the smart grid elements will be integrated. Cross-border energy connections will also be established, ensuring a robust and resilient energy supply in times of need. Cross-sector integration in mobility and heating will also be part of the project initiatives. In Slovenia, grid connections for heavy-duty and fast charging stations will be established, and the power transformer waste heat extraction systems will be built. The result of the Green Switch project will be a grid prepared for the expected large additional loads and renewable energy sources. Green Switch, increasing controllability and strengthening the power networks.
The Connecting Europe Facility for Energy, the European Union's objective to achieve climate neutrality by 2050, is at the heart of the European Green Deal and the REPower EU plan. This calls for profound changes in the energy sector. Europe needs a well-integrated, competitive, and decarbonized energy market that secures energy supply. The Connecting Europe Facility for Energy is an EU funding instrument providing grants to energy infrastructure projects to realize these goals, supporting investments in building, developing, and modernizing cross-border energy infrastructure. For 10 years, the aim of the program has been to support projects of common interest, PCIs, in the fields of electricity, gas, smart grids, and CO2 networks. As of 2024, the program also covers new project categories, such as offshore electricity grids, hydrogen infrastructure, and smart gas grids, which strengthens the drive to decarbonization. The Connecting Europe Facility for Energy also supports renewable energy projects. It focuses specifically on cross-border cooperation and supports renewable energy projects developed jointly by European countries, covering offshore wind, district heating, and solar energy, among others. The Connecting Europe Facility for Energy has so far invested 6.3 billion euros in more than 160 projects, and it plans to invest more than 3 billion euros by 2027. CINEA, the European Climate Infrastructure and Environment Executive Agency, has been entrusted by the European Commission with the management of the Connecting Europe Facility for Energy and Transport. Follow us for more information on our projects and on funding opportunities.
The longest and deepest underwater electrical interconnection in the world becomes a reality. The new subsidiary of the group, the Great Sea Interconnector, will interconnect for the first time Cyprus and Israel with Europe through Greece, changing the energy map in the Eastern Mediterranean. The project has already started, and in the coming years, the Great Sea Interconnector will offer Cyprus high energy security, as well as green and cheaper electricity supply. The new energy corridor will boost exports of green energy produced in Greece, contributing to the energy transition of Europe and the Middle East. The project is co-funded by the European Union. The story of hydrogen begins with the Big Bang, billions of years ago, when various cosmic events led to its creation, along with other light chemical elements. It was discovered by Robert Boyle in 1671. Almost 100 years later, in 1766, hydrogen was recognized as a distinct chemical element. A few years later, in 1781, hydrogen got its official name from the combination of the two Greek words, hydro and ienis, when Antoine Lavoisier and Pierre-Simon Laplace discovered that when this chemical element is burned, it produces water. This makes hydrogen one of the purest forms of energy found abundantly in nature. In fact, 75% of the universe is consisted of hydrogen in various forms. Even the sun produces its energy from the reaction of hydrogen atoms under pressure. Even though it is colorless, hydrogen can be categorized as gray, blue, brown, turquoise, and green hydrogen that comes from water electrolysis with the use of green energy and is considered the cleanest form of hydrogen. Today, rapid climate change, the need for more environmentally friendly solutions, and technological evolution lay the foundations for the future of energy. Hydrogen is coming back to the forefront as the fuel that will lead us into a new, sustainable, and clean energy era, led by DESFA. With investments in specialized personnel, the development of new technical and operational skills, the upgrade and proper preparation of the existing network, and the construction of new 100% H2-ready pipelines. We work to ensure a 100% compatible network for the safe, fast, and reliable hydrogen transmission and storage. At the same time, we plan new infrastructure projects and develop synergies aiming to build up the Greek hydrogen value chain, paving the road for a greener and more sustainable energy future. The future of hydrogen. DESFA. Enabler of a sustainable energy future.
Meillä on sähköjärjestelmä puhdistunut tuossa heti, kun Venäjän hyökkäyssota alkoi, niin Venäjän likainen tuonti jäi pois. Sen jälkeen on investoitu kantaverkkoon, sinne on tullut käyttöön noin 6,5 gigawattia uusiutuvaa tuotantoa. Jos me nyt verrataan tämän päivän Suomen sähköjärjestelmään, niin meidän päästöt on noin 1/10 EU 25 keskiarvosta. Ja Aurora parantaa tätä edelleen, kun me saadaan puhdasta vesivoimaa, tuulivoimaa tänne Suomen järjestelmään. Meillä on käyttövarmuus perinteisesti ollut 99,49 ja seuraava numero vähän vaihtuu. Otetaan niin konkretian kautta viime tammikuun tilanne. Erittäin kylmä pakkasviikko. Meillä vähän jäi tuotantoa pois Suomesta käytöstä erinäisistä syistä. Ja nyt meillä Aurora tuo noin 30% lisää siirtokapasiteettia Suomen ja Ruotsin välillä, niin sitä kautta ihan varmasti meillä on paljon parempi näissä niukkuustilanteissa ennen kaikkea tämä kantaverkko käyttövarmuus. Euroopan unionin tasollahan katsotaan niin kuin Euroopan näkökulmasta, että missä ne pullonkaulat järjestelmässä on, ja tämähän on aikoinaan tunnistettu yhdeksi niin kuin pahimmista pullonkauloista sähköjärjestelmästä. Et sitä kautta tietysti se hinnanmuodostus, tämä stabilointi hyödyttää koko yhteistä aluetta.
In Slovenské elektrárne, we believe that decarbonization of power generation is vital to energy transition and combating climate change. As the biggest electricity producer in Slovakia, we have a long history of construction, operation and maintenance of hydroelectric installations. With the energy transition in progress, intermittent renewable energy sources like wind and solar will add up in the Central and Eastern Europe. To address the grid stability challenge, Slovenské elektrárne has decided to build on its vast experience and combine hydroelectricity with an innovative approach to storing electricity. In north-central Slovakia, we are introducing SE Integrator, a project aimed to modernize the country's most important pumped storage power plant, Čierny Vár. With an installed capacity of over 735 megawatts, it has been helping to stabilize the Slovak power grid since 1982. SE Integrator is an innovative project aimed to increase the pumped storage plant's efficiency and regulation capacity, as well as hybridizing it with a battery system with a minimum of 70 megawatt installed capacity, which will be able to provide up to at least 105 megawatt hours of electricity. Combining the fast response time of the battery, backed by the bulk energy storage capacity of the power plant's water reservoir at the same site, it will require no additional grid capacity, saving it for renewables or for the industry shifting to electric, rather than fossil fuel-run technologies.
I am keen on having hybrid projects, pumped hydro with batteries. If you attach 1-hour battery storage to pumped hydro using the same switchyard, you have a very valuable grid stability tool.
Avoiding carbon emissions, SE Integrator will bring new grid regulation capacity, needed during the transition from the soon-to-be decommissioned fossil fuel sources. This evolution of grid balancing will help to bring in more renewables, and to keep out the risk of blackouts. The project is in common interest of the countries neighboring with Slovakia, since the additional regulation capacity will be shared through the MORI and Picasso platforms. The environmental impact of SE Integrator is negligible, because the battery system would be located on site of the original pumped storage plant, which will also get a turbine upgrade. The project is a crucial contribution to the implementation of the Slovak Integrated National Economic and Climate Plan, and it plays an important role in the Fit for 55 and Repower EU strategy. On our way to reaching the climate goals, the existing power and network infrastructure will crave for cost-efficient and environmentally friendly answers to the challenge of decarbonization. Our answer is SE Integrator, clean, smart, and flexible.
Europe is making its way towards a climate-neutral future. To achieve this goal, it will need to import 10 million tons of renewable hydrogen by 2030. More than 40% of this target could be reached thanks to production centers in North Africa, where solar and wind are abundant resources. But how will Europe and North Africa be connected? The solution is called South H2 Corridor, a 3,300-kilometer dedicated hydrogen pipeline linking North Africa, Italy, Austria, and Germany. It is developed by the 4 European transmission system operators for gas: SNAM, TAG GmbH, GCA, and Bayernets. All the individual TSO projects were included in the first list of projects of common interest under the revised 10E regulation, published by the European Commission on April 8, 2024. Being part of the European hydrogen backbone, the South H2 corridor plays a key role when it comes to establishing an interconnected and diversified hydrogen market. Significant CO2 savings will be achieved in all countries, thanks to the supply of large quantities of clean hydrogen to the main, hard-to-abate demand clusters along the route. The South H2 corridor uses existing infrastructure for over 65% of the route. Repurposed natural gas pipelines are the most effective, competitive, and sustainable transport method. This ensures the effective supply of hydrogen at competitive prices. Thanks to a significant transport capacity, the South H2 corridor will give an important contribution to achieving European and national climate goals, as well as diversifying hydrogen import routes, ultimately ensuring security of supply.
Implementation of smart grid infrastructure is key for development of European energy market. The projects Econ and Danube in Grid focus on mass deployment of cutting-edge smart technology. This will enable to monitor and manage grids remotely, which means that the grid parameters can be flexibly adjusted and the failures can be managed efficiently. The projects focus on strengthening cooperation between distribution and transmission system operators, both on national and cross-border level. This will speed up modernization of our electricity grid and will enable high capacity for integration connection of renewable power sources. We are installing smart devices which will increase quality and security of supply, which means better reliability for our customers.
Arola Line on voimajohtoprojekti, joka yhdistää Suomen ja Ruotsin sähköverkot toisiinsa. Sen pituus on yhteensä 380 kilometriä, josta Suomen puolella 200 kilometriä. Suomen puolella se alkaa Muhokselta, menee Keminmaan kautta Tornioon, jossa ylittää rajan, ja Ruotsin puolella se jatkuu siitä Jokkmokkiin, ja siellä olemme Messaaren sähköasemalla. 152 kilometriä otetaan käyttöön jos nyt 24 syksyllä. Ja sitten se viimeinen osuus Keminmaalta sinne Ruotsin rajalle ja Ruotsin puolinen valmistuu 25 vuoden lopussa. Siis totta kai tämä on valtava iso hanke, iso voimajohto, se on jaettu useampaan osaan Suomenkin puolella, mutta sitten suurin haaste tässä on ollut se, että täällä on hirveän paljon soita ja siellä on paljon pehmeikköjä ja rakentamista ei ole voitu tehdä kesällä ja syksymärillä. Suurin osa rakennustyöstä on jouduttu tekemään roudan aikaan eli talvipakkasilla. Ihanteellinen keli on sydäntalvella, kun päivä alkaa pidentyä. Että on pitkät päivät tehdä töitä, mutta maa on tarpeeksi jäässä, että päästään kulkemaan eikä aiheuteta maastovahinkoja. Ruotsalaisten kanssa meillä on ollut tiivistä yhteistyötä heti alusta lähtien. Yva-vaiheessa varsinkin soviteltiin aikatauluja ja niitä, miten toimitaan ja miten edetään. Ja sitten nyt rakentamisen vaiheessa meillä on kummallakin puolella omat projektit, mutta sitten meidän täytyy totta kai sovittaa se Tornionjoen ylitys, että saadaan aikataulutettua sillä tavalla, että kaikki menee hyvin.
Aux origines, il y a un lien, une histoire, un héritage commun entre les deux territoires. Le projet Celtic Interconnector s'inscrit dans cette culture celtique qui, aujourd'hui encore, unit l'Irlande à la France.
Hi. We have Mr. Thomas Manjoglu. And your project is Grebe Smart Grids, so a smart grid PCI. And finally, we have Mr. Tom Pinnock. Your project is the Belgian hydrogen backbone, a hydrogen PCI. So we've got a great cross-section of different projects here. And we've had a good couple of days of sessions discussing different aspects of PCIs, of the way the CEF works, and how we're bringing forward the most urgent and necessary projects to help Europe deliver on grid integration and to get grids to play their role in the transition, the energy transition across Europe. Today we're going to focus on not only the normal good things that we expect in a PCI project, but the innovative aspects of PCI projects, which basically are helping to make the projects future-proof. And today we selected to talk about, in particular, the ideas of how to introduce innovations into our projects, whether that's innovative technology, innovative deployment, some aspect of innovation which helps make PCI projects, perhaps your projects in particular, future-proof and resilient. So one aspect is the innovation aspect. A second aspect that we want to talk about today is the aspect of adaptation, making sure that the projects that we're building today are future-proof from a climate change perspective. Whether we're talking about the horrible floods that we'd like to pick up is the security aspect related to, well, either cyber security or physical threats to infrastructure. Again, this is a growing fear that our projects are subject to these risks, whether it's underground, undersea cables in the Baltic Sea or elsewhere. There are threats to the security of these infrastructure. And again, if you have ideas and suggestions, best practice of the best ways that projects can identify these and pick them up. So that's the scope of today's discussion. And so perhaps I'd like to start off, and it can be a question to all of you if you want to respond. We start off with the question of innovation in either your project or where you see an obvious role for technological or other innovations in developing infrastructure. Would you care to start, Tom?
Sure. So I want to emphasize back to Fluxys, Fluxys Belgium. In April of this year, we were appointed by the Federal Energy Minister as a HNO, so operator for the hydrogen network. And with the decades of experience we have as a TSO, we have several innovative features in our network which we want to integrate in a future network. And I can give you some examples. The first one is linked to leakage, and therefore we use in our network the CHARM technology. CHARM technology is a LiDAR technology, so a light pulse technology, where with a helicopter, so airborne, we detect a leakage. And we have experience since several years on CH4 on that, and we are analyzing that for hydrogen as well. The second technology we already use and we want to use as well for hydrogen is a thread scan. And thread scan is a system where with hydro pulse equipment we measure the sound in the pipelines. And with that sound, it corresponds with hazard situations, with damage, with cars are running over networks. And with detecting these signals, we can detect what risk can occur with works around the pipeline. So thread scan is a second technology we use, and a third example I want to give is on reuse of existing pipelines. We are now currently with our PCI project looking into new pipelines, but in the near future we want to reuse existing pipelines, and therefore we have to deal with additional testings, innovative testings, to see if the existing material can be reused. So in a nutshell, these three I wanted to highlight to emphasize the innovative work we are doing to have these hydrogen pipelines in the ground.
Thank you. These are three great examples. It's really interesting to hear. Thank you. Thomas.
Hello, everyone. My name is Thomas. Thank you for having me today. I'm representing the Gabretta Smarty project, which we develop with our colleagues from Weinberg, and I work in EGD. Both are the DSOs. So quite old-fashioned business comparing to probably others. We were here today. So I was thinking what's innovative on what we do, honestly, as it's quite old-fashioned business, the wires, copper. And what we currently do is to adapt on the change which is going around in the energy business in general, and mostly emphasizing the role of the DSOs. Because most of the change, all the sexy buzzwords are happening in the DSO grids. Flexibility, aggregation, decentralized energy production, households, PVs, everything is mostly connected to the DSOs. And we try to adapt, honestly. And there are two ways. First one is to invest in copper heavily to make the grids, stronger and more resilient. This is not very innovative. But there is another part to do it a little bit smarter, to combine those two attitudes, as it is not always possible to just invest in the copper because it costs a fortune, so you need to combine it somehow. And there are, I would mention two main outputs of our project. The first is physical interconnection on the DSO levels. So we came up with the two new interconnections with a DSO Weinberg. It doesn't seem really innovative, but honestly, both of our grids are operated on the different voltage level and so on. So to come up with a technically viable solution, how to connect two different grids, were kind of a nightmare sometimes, but hopefully we managed. And I'm looking forward to the start of the construction in upcoming, hopefully, 2 years. So this is one kind of the stuff I believe we can handle the upcoming energy future, to not interconnect only on the TSO level, but be able to also use the DSOs, interconnect on the grids on the DSO level, and really have the interconnected European energy market. Because currently we will use it in N-1 situations, so it means in emergency cases. That's the outcome of those investments. And the second, we also use the advantage that both of the companies are part of the EON world. So we are developing, let's say, IT tool which will be focused on the prediction of production in our distribution grids, mainly PVs, and to be able to predict what will happen in our grid, and also to adapt real time on what will happen to be able to more efficiently steer the grid. So we want to come up with a one common solution, which will be afterwards applicable, hopefully, among the other distributors in our company. I mean, the E.ON part. So that's maybe two examples what we do.
That's great. Thanks. Very good to hear. Smart interconnections of systems is always good. Thank you.
Thank you.
Katrina, over to you. And maybe everything is innovative when it comes to CO2 networks, but I'll leave you to identify one or two examples.
That's true. It's on. Okay, thank you. That's true, and thank you very much. I'm Katerina Sardi. I represent Enerth. Enerth is a company of the Energean group of companies, and we are developing a Prinos CO2 storage. We are a PCI together with the Greek gas transmission system operator, DESFA, who are developing a gathering system in the south of Greece. We, as a storage facility, are located in the northern part of Greece, and I'm afraid we're innovative by definition, in the sense that we are developing the first CCS chain in the South Med. We are developing and planning to inject CO2 in a depleted oil reservoir saline aquifer. It hasn't done before. This is an TRL 8 to 9 anyway. We will be extracting water to maintain pressure and drive the CO2 to the deeper part of the reservoir by using multiple ESPs. Here comes another innovation. We are trying to accommodate the demand of various clients, because this is only part of a CCS chain. This is not an integrated chain as it has happened in many parts of the north of Europe. So we are only offering a storage service with our clients delivering the CO2. So we need to secure an operating envelope for them, working also on CO2 specifications. This comes in different part of innovation. And we are developing this as an open third-party access terminal, offering capacity under non-discriminatory conditions with taking ideas from energy infrastructure, electricity and gas, and the way that capacity has been accommodated there. So this is an overview of basic innovations. Another part is that we need to have a very stringent monitoring plan to ensure that no CO2 escapes. And this means that we shall be working towards innovative techniques for monitoring CO2, and in parallel, we are offering Prinos CO2 as a testing ground for European developers that are actually, in the time that we're talking, developing these kind of sensors. We participate in 2 Horizon projects, CORIU and Hercules, and as part of the tasks under these projects, we are offering Prinos for testing for sensors and also for software that models the migration of the plume inside the reservoir.
Thanks. That's really interesting. It's also good to hear of the linkage up between Horizon Europe, the EU's research program, and making use of that research in subsequent EU projects. That's a nice synergy of EU programs, which is a nice example to have. Anders, over to you. And I mean, again, the whole idea of an energy island is innovation in itself, an island which is an interconnector, but perhaps you can elaborate.
Yes, thank you very much, and happy to be here. And if you like synergies, I think the Bornholm Energy Island is a very good example of synergies between different PCI projects, because I've also worked on the North Sea Wind Power Hub program, which is a subsidized program to develop the concept of the energy island. So the Bornholm Energy Island is really one of the first examples of how to implement this concept of offshore energy islands. Now Bornholm is an island, so that's the reason for that is that we can use these new technologies onshore, so in a safer environment, and in that way de-risk the project for the developers and for ourselves as well. So there's a lot of innovation in these energy islands. The whole project is innovative in that sense. Just to make it a bit more concrete, in North Wind Power we looked at it from system perspective. So we need a new shift in system thinking around this. It's not just plugging in a new wind farm. It will have effects onshore, offshore. It's also the technical feasibility. How can we do this going forward? I can mention DC breakers as one of the big technologies that I can also get back to. We've also looked at the market design around this. We need new market setup, so we found that offshore bidding zones is the way to go. And there will be a new offshore bidding zone around the Bornholm Energy Island, specifically to meet this. We've also looked at cost benefits. So there we also need to be innovative, because the usual cost-benefit analysis, they don't hold up anymore when we're looking at these kind of big projects. So there's a lot of innovation in the Bornholm Energy Island, and I mentioned the direct current breaker. So that's something we need in order to maintain the N-1 that was mentioned before. It's not developed fully yet in Europe. So what we've done in the Bornholm Energy Island is to prepare the setup and our assets, so that we can install a DC circuit breaker later on. Another part of innovation that I want to highlight is standardization and modularity. So in order to take this concept to the next level, not just one island here and there, but make it a fully integrated offshore mesh in the Baltic Sea, in the North Sea, in the Mediterranean, we need standardization across the different vendors. So Bornholm Energy Island is thought to be able to hook up with other systems later on. But we need multi-vendor and multi-standardization, so that the products from one developer, from one OEM, can talk to the products of another developer. That is hugely important. On the ground, there are a lot of other smaller technologies that are innovative, but these are probably the sort of the main parts that I want to highlight here.
Great, thank you very much. All sorts of different aspects to innovation there. Thank you. Over to you, Michael, and the innovation associated with the Celtic interconnector.
Okay, thank you. I suppose first of all, just to recap on what the Celtic interconnector is. So it's effectively a 700 megawatt interconnector that's connecting the Irish grid in Ireland and Cork to the French grid in Brittany. So we received grant funding back in 2019. We've signed the contracts in 2022, and the project's due to be complete in 2027. So that's a 575 kilometre interconnection from France to Ireland. And it's really critical for Ireland for a number of reasons. But the first reason is security supply. To give us that security that when we're actually short of electricity, we can import the electricity from France. The second reason is to connect us to the European market, because since Brexit, we don't have any direct connection to the European electricity grid. And the third reason then is to hit our renewables targets. And what's really critical now is that Ireland has been set a target to achieve 80% of our electricity coming from renewable sources by 2030. And we're somewhere in the mid-40s at the moment, but to get to 80%, what's really important to that is interconnection, so that we can import and export. But other innovative technologies that we've already implemented in the system. In particular, what's really important for us to achieve that target is we need to be able to operate the system at up to 95% SNSP at critical times to reduce the amount of thermal generators on the system. So we need to delicately balance interconnection, all of the wind and the solar that's been produced, all of the storage that's been connected to the system in Ireland, the integration with our distribution system and the transmission system, to delicately balance the situations that when there is plenty of wind and there is plenty of sun, we can reduce the amount of carbon generation on the system and really focus on maximising the renewables. What's really critical behind all of that in terms of innovation, though, I'd say, is about engagement. And I've just come from a talk here this morning in terms of engagement. But what we realised is actually to deliver those targets, we need to deliver new infrastructure. To deliver the infrastructure, we need a common understanding and acceptance from communities to allow us to build the infrastructure. So we've taken a lot of learning from how we've actually developed the consenting process in Celtic, and we're applying that to all our other projects and sharing it with our colleagues out here, because that's really critical for us in terms of actually hitting those targets.
Great, thank you. Wow, I think I've been impressed and a bit surprised by the variety of different innovation we have just in 5 PCI projects here. We've heard of community engagement and novel ways of building up consensus and a sense of the need. We've had regulatory novelties and innovations, lots of technological innovations, but also institutional innovations. So there are multiple dimensions to the way that PCI projects are grappling with novelty, building it in to make successful projects, and really showcasing how we can safely embrace innovation and build the future-proof grid. Thank you very much. That's great. Okay, so that's our park innovation for now, and we move on instead to adaptation, which has an innovative aspect. But again, for all of you, you're to varying degrees perhaps aware of the implications of even the short-term changes in weather patterns and extreme events that are associated with climate change, and the need to make sure that these are factored into projects which are going to last for decades. So perhaps if you can give examples of your projects or in your areas of how you've identified these new risks and how you've factored this into your planning, your processing, or your investment.
Okay, that's a very interesting question, but it's a question we already asked decades ago, because the threat is now real with what happens in Spain, but it is there and was there already decades ago. So if I'm pointing out now our PCI project, where we want to construct a backbone network, a pipeline network, operating a pipeline network, is nothing new. And I want to put some highlights on what we do already with existing pipelines, and we want to integrate on the new pipelines we want to construct. And first of all, a backbone must be visualized. So we need to put beacons on the pipelines in order to have that recognizing point for the public in general. We also have inspections we do on a regular basis. Inspections by foot, inspection by car, and inspection by helicopter. That's something we want to do as well for the hydrogen backbone. But then on technological side, we have the threat scan and the charm I just explained, but also the cathodic protection we put in, and the inspections we do on the pipelines itself. Now the question you will ask to me, well, what has it as a link with floods or with other weather conditions? Well, we have a certain organization behind that, an emergency organization. We have the operating part, which I just explained, but we have also the emergency organization, where staff is trained, is drilled to be able to respond to hazards around the pipeline. For example, if a pipeline is flooded, and you have terrain which is excavated, and you have a free pipeline due to the weather conditions, our teams are ready to be able to, in 24 hours, 7 days a week, to be able to respond to those hazards. Teams are ready as well to the technical changes if it's necessary. To respond with the public, to respond with the municipalities, with the government if needed. So there's an entire program behind it to respond to hazardous risks. Since the pipeline itself is underground, we have some hazards due to weather, but it's slightly slim. It's not big conditions we need to consider. But again, with the organization we have around the existing pipelines, we want to proceed and use them as well on the new pipelines. So it's a little bit of history. We take, we renew, we put it in a box, we reshuffle it, we see how we can cope with future demands, and we adapt when necessary. But we have a good baseline to start with.
Great, thank you. Thomas, over to you. DSOs and how they cope with change, including changing weather patterns and expectations.
Yeah, so we live in the world where we talk about decarbonization mostly. And as we know that decarbonization, it's not possible without electricity, right? So as I always say, my business is a future as we mainly distribute the electricity. So that means that the resilience of the grid and -1 resilience are our top priorities. So we try to build the grids as strong as possible to withstand whatever is coming. But it, doesn't work usually or always. There are the cases when it collapses, honestly, so that we can't deliver the electricity. Then we have operational excellence, so it means to get back as it was as soon as possible, SAIDI, SAIFI criteria, whatever. But then there are even cases that this is not possible. So I think I talked once about that, but we had a tornado in Czech Republic, which is not really common stuff in our geological area, not USA. So we had a tornado which totally destroyed the 110 kV line, where was just only one customer, and it was the underground gas storage. And it was right before the winter season, and it was one of the most important gas storages in Czech Republic. So kind of an important customer. And we knew that in that situation, and even there was a crisis with the steel, so we knew that it will take at least half a year to build a new line. But luckily, and here comes the point of my short speech, we had an interconnection with a colleague of ours from Slovakia, that N-1 interconnection with other DSO, so international cooperation. So we were able to switch on the line, which already existed, and deliver the electricity from the colleagues from Slovakia for, I think, more than a half year in a row. So we were listening for years that we were building the lines we are not using because they are just for those situations. And everyone said, hey, we are spending money on stuff we will never use. But believe me, once the situation is on the table, you are pretty glad that you invested in something you don't want to use, but the situation can come, and then you are pretty glad that you did that kind of decision. So that's what I always say when someone says to me, why are you doing this and that with colleagues from Germany? We will never use it. It doesn't make sense. You're investing in money with no added value. And I said, you never know what's coming on. The customers are pretty dependent on us. If you have, heat pump and, e-car and everything, we are part of their lives. So we need to do our best and even invest in the stuff we will never use if something is going on as it should. But you never know.
Terrific. For the European Commission, we always love to hear stories of why interconnectivity across member states is important and good and useful and provides value for money. Partly it's in the day-to-day functioning of the grid, so the greater interconnectivity enables greater integration of renewables, as is the Irish case with the interconnector, but both on a daily basis, but also dealing with extreme events. You mentioned a Czech tornado, but we have other stories more recently, the last couple of years, of problems of frozen rivers blocking supplies and relying greater on existing interconnections. So fundamentally a nice reminder of the role that the 10E and PCIs and CEF play in building up the security and the resilience of the European networks, energy networks. Thank you. And building a future CO2 network that's also future-proof in the face of climate change.
Yes, yes, indeed. And actually, I want to touch on 3 different aspects on this. One is, well, our CO2 storage facility is being developed in a rather benign area. We don't have extreme weather events, or at least we used not to have. So the project is in a fast-track development procedure so that it could be available by 2028 and contributor to the Net Zero Industry Act. In this context, we have submitted our environmental and social impact assessment to the relevant authority back in August, and we have taken into consideration potential extreme events, high winds, floods, tornadoes, and so on. This assessment and also the mitigation measures, this builds on the existing environmental action plan that we have in place, and also we have a flood risk management plan. This is a 40-year-old facility, so this understanding and knowledge is in place. For example, the flood risk management plan is it contains 5 levels of implementation. And also, what is main to this is the creation of water drainage systems to collect water in case of extreme rain conditions. These kind of systems exist in the existing facility. Naturally, they will be further upgraded for Brino CO2 storage. We also have an in-house fire brigade and fire addressing facility. And what is important there, and I want to stress also, adding from what Tom said on cooperation, we cooperate with our neighboring industrial facilities. We do organized drills, all the industrial facilities in the area, see how we can share equipment, share plans. So, because what experience has shown to us, still limited, of course, thank God, is that one would need all the help that one could get, and in an organized manner. So this is one point that I would like to make also for the potential support of the Commission, because CCS chains are very new. Experience does not exist. Of course, they are industrial facilities, so drawing from experience from industrial facilities, one could gain and address issues, but another topic is that for example, in the Med, there are not a lot CO2 storages. What is going to happen if, for example, Ravenna is not available, but Prinos is? Yes, here we and both of them exist. Here we have a resilience pair, and overall, and vice versa, of course. So resilience pairs need to be developed in CCS chains where infrastructure is scarce. Tom mentioned about N-1 and electricity network availability. This is something that does exist to a major extent with electricity, to an extent also in gas, to a good extent. But for CCS chains, which are very new, this is something that probably needs to be a focus.
Okay, that's great. So in addition to the narrative of interconnectivity as being a defense in the face of climate change and the need for adaptation, resilience just in the nature of cooperation amongst projects or nearby associations. And both interconnectivity and such cooperation across institutions acts as a cost-saving measure. So this is really something that's helping minimize costs of project development if you can share resources at different times of need. So another good example. Thank you. Over to you.
Yes, so the Bornholm Energy Island is also all about interconnectivity and connecting electricity grids from different countries. So there's that, which also plays into climate adaptation. More specifically, the Bornholm Energy Island is built on an existing island in order to test equipment that we will later on put on platforms offshore. And the environment offshore is very, very harsh. A lot of wind, water, salt. So putting it onshore is a way for us to test how it will act under different circumstances and to monitor it more closely in order to prepare later on in other projects to move similar equipment offshore. So in that sense, we are still learning and using this project to learn from. Specifically for the equipment that we will put on the Bornholm Energy Island, we will have in the tender material we have put obligations that needs to be fulfilled in order for it to meet the most extreme, still realistic, most extreme scenarios that we can envision. This equipment will stay for decades and beyond. So we need to prepare for eventualities like that.
Great. So yes, so some real, actual physical testing of different technologies and approaches to dealing with changing weather conditions and very hostile, perhaps the most hostile types of conditions infrastructure can face.
Yes, testing it in a bit more benign environment first in order to be able to integrate it offshore in a lot more hostile environment later on. And that will also help us prepare in a more broader sense for climate adaptation, I would say.
Michael, tell us how adaptation to climate change has been a factor in your project development.
Okay, so a couple of things really probably around asset management in that context. So the first is when we always look forward in terms of developing new projects, very focused in terms of flood risk in particular, and looking at, for example, what the predictions are in terms of the sea level rises and how that's going to actually kind of completely change the environment. And we're doing that for future projects, but we're now in the process of actually looking at our existing infrastructure and looking at the flood defence systems and probably needing to upgrade a number of locations in Ireland because of the flood risk that's actually there, including actually our control centre is something that's located in a part of Dublin that potentially in 10 years' time the seabed level will have risen. So we're kind of trying to factor that into our future plans in terms of locating. The other thing maybe to mention as well is that with our national infrastructure, and when you think of overhead lines and pylons and that, while it's quite resistant to the elements and it really stood up, one of the big challenges we have is that we don't have enough time in the year to carry out all of the maintenance that's actually required. In particular, because we tend to lock down the grid as much as we can during the winter months to give us that extra N-1 resilience that's actually there. But to carry out all of the maintenance and actually to develop all the new projects that we have to expand the grid to meet the climate targets, we're probably taking a more risk-based approach in terms of the amount of maintenance we carry out, but also how we balance and how we predict where the weather is going to be in the winter months to allow us to carry out and maybe take slightly greater risk in terms of the level of redundancy, like N-1, N-2 we might have in certain parts of the network to allow us to get that critical those works delivered. And that's something we didn't have to look at a number of years ago, but it's going to be more and more critical now. And the ability to manage that with an ever-changing climate can be a challenge.
Great. There's two very different dimensions to adaptation there. There's almost the classic long-term expectation of rising sea levels and needing to build that into the longer-term planning of how every step of the infrastructure is able to cope with that particular factor. But then also a very short-term aspect of the changing weather conditions affecting your annual maintenance program and the need for adaptation in just reflecting how increased levels of storms or just different weather factors like that can disrupt a very what you might think of as a very standardized, traditional, ongoing regime, your maintenance regime. Why does that need to change? Well, this is an example of why that needs to change and why you need to also reflect on that aspect. Thank you. Okay, again, I don't think we've chosen, these are very good projects, but I'm starting to get the feeling that I could have chosen any 5 PCI projects because they're all really good. And we've got 5 classically good projects here which are really illustrating innovation, novelty, forward thinking, really gearing up to be fit for the future. So these are impressive projects to hear about. Now we turn to a third dimension of being future-proof and gearing up for a growing fear, a growing perceived risk for all energy infrastructure, that of security risk in terms of cybersecurity or even physical threats to infrastructure. And perhaps we go back the other way this time when we start with the interconnector, and whether or how you've thought about either cyber risks or other security risks and have built that into your planning, your management of the project.
So I think, first of all, in terms of general security, these pieces of infrastructure, they're so critical in terms of their effect on the grid and the impact of actually losing them, that yes, we have factored in additional physical security and monitoring of the key converter facilities, but also in terms of where we locate all of the equipment. I think the bigger challenge is actually on the cyber side, because when we developed the project many years ago, and then we went out through a tendering process, and then you sign a contract, and then you're delivering it, suddenly what you're looking at from a cyber point of view can be out of date. So we're finding ourselves constantly going back and saying, well, what's actually changed now? And it's almost an open door, I think, on some of these projects where you're never finally signing off on the level of cybersecurity that you need to have on these projects. Because if you do, you're going to miss something. And it's that constant kind of working with your suppliers, working across the industry, seeing what's changing, and being very open and willing to take on additional measures, to spend additional money as well, just to reduce that risk, because it's ever increasing every day. And I think it's very different to buying a piece of equipment and expecting the piece of equipment to deliver. When it comes to the technology that's operating that equipment, I don't think we're ever going to end and say, okay, this is what I'm buying and it's in this box. I think that box is going to continue to adapt, and we have to be ever vigilant on the cyber side to figure out, well, what additional measures do we need to be built in. And I think that's the open approach I'm finding interesting in terms of projects like this, is the technology aspect will never end.
Yeah, a huge and novel challenge for all of us, I guess. What's happening in your project?
Yes, a huge challenge, and I agree completely with this is an ever-developing, ever-changing challenge, so we just have to be able to adapt. It's a bit like an arms race in that sense. So maybe I'll talk more about the physical integrity side of the grids, and there's only so much we can do from TSO side. There are sector responsibilities, so we have responsibility as TSOs and DSOs. There's also huge responsibility, of course, in the military, in NATO even, and the national security agencies. But maybe going into the helicopter view a bit on this, one of the learnings that we see from Ukraine right now, and I think in the TSO world we are very, very impressed with how they're meeting the challenge in Ukraine. You have a country with one of the biggest military in the world that have been trying to destroy the energy sector in a smaller neighboring state, and they have not succeeded. That is very impressive. What we see, what we hear from them that they have managed to do, or what they have learned, is that the more decentral an energy system is, the more robust it is, the more difficult it is for an adversary to take it out. So looking at the Bornholm Energy Island project and interconnector, I think that plays well into that. On one hand, you can argue that 2 gigawatt, 3 gigawatt on one island is a big project and a risk like that. But what we're looking at is not the individual project, but rather the opportunity to harvest up to 300, 500 gigawatt of offshore wind, also onshore. And when you look at it at that scale, 2 or 3 gigawatt is a small component. So in that sense, in 20 years from now, if one of these 2 gigawatt hubs fall out, there will be others and other ways in a mesh grid that the electricity will flow. So I think what we are looking at now is sort of the first steps in an integrated system across European states that will make our energy systems more robust to different threats that we will see in the future.
Thanks, but perhaps I come back to you on this, because we've been talking of the benefits and the cost savings and the system-wide benefits that come from greater integration, greater interdependence. And indeed, we see this now with Ukraine, where we're doing our utmost to improve the connectivity between the EU and Ukraine to help them cope with the attacks they're under. And yet you said that a decentralized system can be better insulated against such attacks and such a threat. Is that a contradiction, or how do these two stories meld? On the one hand, we've got the benefits of interconnectivity, but interconnectivity is interdependence, and does that create vulnerabilities if we're safer in decentralized systems?
The European system is already very interconnected. So if one falls, there's a risk that others will fall. So it's in all our interest that none fall, and if they fall, that we help each other out. And this is exactly what we can do with interconnectors. So the more interconnected Ukraine becomes in the European system, the better we can help them out in their part. And it's possible to take out one cable or one hub, but if there are the more cables, the more hubs that there is, the more difficult it is. So what we see in Ukraine is that it's more safe for them to have a wind farm, onshore, offshore wind farm, where it's difficult to take out all the wind turbines instead of one big power plant. It's easier to hit that one. If we scale that up to the European size, it's the same principle applies. Now we're not looking at individual turbines necessarily, but at interconnectors, at energy hubs, at more connections. So say there is a ship sailing around the North Sea in 2050 and cutting the cables. They would need, in a fully meshed system, to cut a lot of cables to really challenge the energy security of that European system in 2050, which we've had investigated also in the North Sea Wind Power Hub.
Okay, good. That's clear. So very clear, simple messages there. The more wind turbines, the better, and the more meshed our systems are, the better. Thank you.
Okay. Energean operates in 7 countries, so we have a security plan in action. Nevertheless, one point I want to make is that these kind of infrastructures that we've been discussing about, hydrogen networks, interconnectors, CO2 storage facilities or CCS chains, they shall need to be considered. I mean, they are already in many countries as essential infrastructure, and probably they need to be looked at into a bit further on how they could be supported, because this would need a government/EU intervention. I mean, the type of malicious attacks that we have seen in the Baltic interconnectors, in Nord Stream, it's not something that usually an investor is prepared to address into that extent, and certainly not the insurers, this is another important point. On cybersecurity, we already have an operational technology plan in process. This relates to having a separate non-accessible network for operation in all our assets. This would also include Prinos CO2 storage, one-way data systems, monitored third-party access, and firewalls, which is being addressed and updated almost every day or every week. We have in place what we call a cyber crisis management plan, again with different levels of readiness and alarm levels that are being in place whenever required, and this is also going to be applied in Prinos CO2. I hope everything works, at least on the existing facilities. I have been approving every day, every year, additional expenditures of plus 30% from one year to another. So probably things are being like state of the art. Prinos CO2 the same, but as a message, again, I think particularly in the cyberspace where changes happen very fast, cooperation and exchange of knowledge, exchange of know-how, exchange of best practices become even more important. And in this case, CCS chains with electricity, with gas, with hydrogen are the same. So probably it's another opportunity for everybody to sit together.
Thank you. I want to come back later on this question of insurance industry and how it's critical to your projects, it's critical to the industry, but they also have to grapple and deal with all of these new or increasing risks. But I might come back to that. In the meantime, cybersecurity from your perspective.
I will maybe follow up, not with a physical security, but about the cybersecurity, maybe not from the perspective of the project. What we currently learned and what we do generally in E.ON, I think we all need a change of mindset. It doesn't sound really interesting, but in the end, the change of the mindset and thinking about the technology, their vulnerability, and so on, it's super, super important. Because what we currently do, we put in our grid thousands of assets which are remotely connected to our supervisory systems, directly connected to our, let's say, crucial systems. We operate the grid and so on and so on. And all the TSOs do it around the whole Europe. And what's really important is the change of the mindset and thinking that this can really endanger what we currently do. So this is one perspective. We do it generally in E.ON. It costs a lot of money in the end, because you have to take, the asset only from some limited amounts of suppliers and so on and so on. You get there another security asset and so on and so on. And that's maybe the helicopter view. But there is another thing I think everyone from us can do. We call it a human firewall. And that's your daily behaving, not only in your business life, but also in your personal life. So think about what you do behind your computer. Don't forget to lock your screen. And there are easily 10 basic steps which can, for zero cost, help the whole company behave secure and, not get more cyber attacks than needed or that will occur. So mindset, and also thinking that you are the part of the whole team, and your personal behavior, even if you think that you are not, the super crucial part of the company, can influence in the end the rest of the Europe. So human firewall, and I would say the behavior and mindset, two really important things.
Great. Coming back to that human dimension, that institutional dimension that we need to factor in as well. Thank you.
Yeah, it's not easy to come as a last one because everything was said was very, very accurate, and I don't want to say again what was said. But like my colleague said, the human factor is a very important one. We see at our company that constantly training the personnel is vital. If I take the example of fishing, you get a simple mail, and okay, you open it. But if you don't have that training constantly, accessing to that knowledge, then you're stuck. So repeating every time these steps is vital, and it starts, like you said, with us. Now for the backbone, without data transmission, you can't operate the backbone. That's why the data transmission, the optical fibers, which we have in parallel with our pipelines, are vital. And therefore, we organize ourselves not only for the steel backbone, but also for the data transmission with a system we call information management system. And again, what my colleague said, it's in 3 steps. We have internal audits done by experts controlling the system. We have our personnel, like I said, which is trained, but also, and that's something was not said, we also hire ethical hackers to see if our system is well conceived, if the technology is still up to date, and that's something we do every year. To see if our system is still okay. For the hardware, and hardware I mean with the valve stations, the transmission stations, which are subterranean. It's something in the project we need to assess at every moment. You can't take a standard which was okay 10 years ago and put it today as a standard. You have to see what the evolution is in the society and adapt your project. For example, we have a terminal in Zeebrugge, an LNG terminal, and still today, and it's in operations from end of the year 1980s. But it's approved. We approved the security step by step, following the society needs. And then the last tank we built there, the concept was that a small plane could not crash into the tank. It was a concept which was not already taken into account in the first tanks, but in the last tanks it was. So you see, there is an evolution, and we can't take for granted the standard we have today for cybersecurity, but we need to evolve in time by time.
Wow. Well, thank you all. That's, again, they easily field off the questions I pose in terms of the innovation and the good practice in PCI projects. Perhaps I'd ask, I don't think these, we've gone through cybersecurity, innovation, and climate adaptation. And I don't think these are necessarily explicit when we do a PCI call and look at projects. But do you recall, probably a while ago now, do you recall flagging up these dimensions to your projects when you were first making your proposals, that you were stressing the innovation, stressing your forward thinking in terms of dealing with adaptation and future cyber risks? Were these things, I mean, you did mention that in terms of adaptation, this is something that you were doing decades ago. So is this a normal part of your thinking as project developers? This is you would expect to see this in every PCI proposal? This is a no-brainer for you. So maybe I'm right. Maybe any PCI would have, up here on the stage, would have been able to answer these questions. But it's encouraging to hear such easy, fluid, and convincing answers as to how we're making these projects future-proof. So I think they're all shining examples. I shall certainly take them away and use them for future debates. Well, I think we're about time to wrap up. So I thank you all for your really illustrative and concrete examples. Your projects are clear flagships in terms of showing how the PCI process can bring forward innovative and really future-proof projects. So thank you very much for participating this afternoon. Thank you.
Si chiama Elmed. È il ponte energetico tra Italia e Tunisia che Terna e Steg stanno progettando per collegare due grandi sistemi elettrici, quelli di Europa e Nord Africa. L'interconnessione energetica e il collegamento delle fonti rinnovabili alla rete sono fondamentali per un sistema elettrico euro-mediterraneo integrato, sicuro e sempre più sostenibile. Elmed è la prima interconnessione in corrente continua tra i due continenti. Un'opera da 600 MW di potenza e 220 km di lunghezza che sarà realizzata tra la stazione elettrica siciliana di Partanna a Trapani e quella di Mlabi in Tunisia. L'attenzione al territorio e alla sostenibilità è un punto fermo dell'infrastruttura, che coniuga soluzioni tecniche all'avanguardia e minimo impatto ambientale. La tratta sottomarina dell'opera prevede la posa a circa 800 metri di profondità di un cavo lungo 200 km che raggiungerà la costa tunisina, nella penisola di Capo Bon, attraversando il canale di Sicilia. Un'opera di interesse europeo che nel 2022 ha ottenuto un finanziamento di 307 milioni di euro dal programma Connecting Europe Facility. Per la prima volta i fondi comunitari per la realizzazione sono stati assegnati, oltre a uno Stato membro dell'Unione Europea, anche a uno Stato terzo. Un progetto concreto che si inserisce nell'ambito degli obiettivi internazionali per una transizione energetica e digitale che sia anche equa, inclusiva e responsabile.
Europe has great challenges ahead. Accelerating decarbonisation and moving towards energy sovereignty by 2030. This is what the European Repower EU plan establishes, and this is how the different countries are working together. To this end, renewable hydrogen is the great ally, clean and produced domestically. The development of a European hydrogen backbone network with corridors linking supply from producer countries to demand centres will be essential. H2Med will be the first EU renewable hydrogen corridor capable of delivering 2 million tonnes of renewable hydrogen, which accounts for 10% of the projected hydrogen demand by 2030. Driven by the governments of Spain, Portugal, France, Germany, and the European Commission, and promoted by the TSOs of the countries, it was submitted to the European Union's Projects of Common Interest application on the 15th of December 2022. H2Med is made up of two interconnections, one between Celórico da Beira in Portugal and Zamora in Spain, and an underwater hydrogen pipeline between Barcelona in Spain and Marseille in France. It will play a pivotal role in connecting the production capacity in the Iberian Peninsula with demand centres in countries like Germany. With this purpose, the national network projects, also presented as PCIs and part of the corridor as a whole, are progressing in parallel. Developing a hydrogen economy will have significant benefits for Europe. Socio-economic, such as industrial development, innovation or investment attraction. Environmental, such as reducing emissions or improving air quality. And social, because it will help a just transition, employment promotion and the development of local economies. There are many challenges, and using the public-private partnership model, we're taking steps to reach the targets set by Europe. It is renewable and can be applied in all sectors, including those with difficult decarbonisation solutions, such as intensive industry and heavy transport. It is renewable hydrogen. And with projects such as H2Med, in Europe it is already a reality. Hydrogen is Europe. Hydrogen is now.
In a world transitioning to renewables and electrification of mobility and heating, distribution and transmission grids cope with the rise in power flows and the lack of flexibility of reactive power. Recognizing the urgency, partners from Austria, Croatia, and Slovenia decided to join forces and tackle these challenges under the Green Switch project. The Green Switch project partners will modernize and digitalize the distribution and transmission energy systems. In transmission grids, new technologies, including power flow prediction and control systems, will be deployed. Dynamic thermal rating will be upgraded, and new components will be integrated into the supervisory control and energy management system. In the distribution grids, substations will be automated, an advanced distribution management system will be upgraded, and the smart grid elements will be integrated. Cross-border energy connections will also be established, ensuring a robust and resilient energy supply in times of need. Cross-sector integration in mobility and heating will also be part of the project initiatives. In Slovenia, grid connections for heavy-duty and fast charging stations will be established, and the power transformer waste heat extraction systems will be built. The result of the Green Switch project will be a grid prepared for the expected large additional loads and renewable energy sources. Green Switch, increasing controllability and strengthening the power networks.
The Connecting Europe Facility for Energy, the European Union's objective to achieve climate neutrality by 2050, is at the heart of the European Green Deal and the REPower EU plan. This calls for profound changes in the energy sector. Europe needs a well-integrated, competitive, and decarbonized energy market that secures energy supply. The Connecting Europe Facility for Energy is an EU funding instrument providing grants to energy infrastructure projects to realize these goals, supporting investments in building, developing, and modernizing cross-border energy infrastructure. For 10 years, the aim of the program has been to support projects of common interest, PCIs, in the fields of electricity, gas, smart grids, and CO2 networks. As of 2024, the program also covers new project categories, such as offshore electricity grids, hydrogen infrastructure, and smart gas grids, which strengthens the drive to decarbonization. The Connecting Europe Facility for Energy also supports renewable energy projects, It focuses specifically on cross-border cooperation and supports renewable energy projects developed jointly by European countries, covering offshore wind, district heating, and solar energy, among others. The Connecting Europe Facility for Energy has so far invested 6.3 billion euros in more than 160 projects, and it plans to invest more than 3 billion euros by 2027. CINEA, the European Climate Infrastructure and Environment Executive Agency, has been entrusted by the European Commission with the management of the Connecting Europe Facility for Energy and Transport. Follow us for more information on our projects and on funding opportunities.
The longest and deepest underwater electrical interconnection in the world becomes a reality. The new subsidiary of the group, the Great Sea Interconnector, will interconnect for the first time Cyprus and Israel with Europe through Greece, changing the energy map in the Eastern Mediterranean. The project has already started, and in the coming years, the Great Sea Interconnector will offer Cyprus high energy security, as well as green and cheaper electricity supply. The new energy corridor will boost exports of green energy produced in Greece, contributing to the energy transition of Europe and the Middle East. The project is co-funded by the European Union.
The story of hydrogen begins with the Big Bang, billions of years ago, when various cosmic events led to its creation, along with other light chemical elements. It was discovered by Robert Boyle in 1671. Almost 100 years later, in 1766, hydrogen was recognized as a distinct chemical element. A few years later, in 1781, hydrogen got its official name from the combination of the two Greek words, hydro and ionis, when Antoine Lavoisier and Pierre-Simon Laplace discovered that when this chemical element is burned, it produces water. This makes hydrogen one of the purest forms of energy found abundantly in nature. In fact, 75% of the universe is consisted of hydrogen in various forms. Even the sun produces its energy from the reaction of hydrogen atoms under pressure. Even though it is colorless, hydrogen can be categorized as gray, blue, brown, turquoise, and green hydrogen that comes from water electrolysis with the use of green energy and is considered the cleanest form of hydrogen. Today, rapid climate change, the need for more environmentally friendly solutions, and technological evolution lay the foundations for the future of energy. Hydrogen is coming back to the forefront as the fuel that will lead us into a new, sustainable, and clean energy era, led by DESFA. With investments in specialized personnel, the development of new technical and operational skills, the upgrade and proper preparation of the existing network, and the construction of new 100% H2-ready pipelines. We work to ensure a 100% compatible network for the safe, fast, and reliable hydrogen transmission and storage. At the same time, we plan new infrastructure projects and develop synergies aiming to build up the Greek hydrogen value chain. paving the road for a greener and more sustainable energy future. The future of hydrogen. DESFA, enabler of a sustainable energy future.
Meillä on sähköjärjestelmä puhdistunut tuossa heti, kun Venäjän hyökkäyssota alkoi, niin Venäjän likainen tuonti jäi pois. Sen jälkeen on investoitu kantaverkkoon, sinne on tullut käyttöön noin 6,5 gigawattia uusiutuvaa tuotantoa. Jos me nyt verrataan tämän päivän Suomen sähköjärjestelmään, niin meidän päästöt on noin 1/10 EU25 keskiarvosta. Ja Aurora parantaa tätä edelleen, kun me saadaan puhdasta vesivoimaa, tuulivoimaa tänne Suomen järjestelmään. Meillä on käyttövarmuus perinteisesti ollut 99,49 ja seuraava numero vähän vaihtuu. Otetaan niin konkretian kautta viime tammikuun tilanne. Erittäin kylmä pakkasviikko. Meillä vähän jäi tuotantoa pois Suomesta käytöstä erinäisistä syistä. Ja nyt meillä Aurora tuo noin 30% lisää siirtokapasiteettia Suomen ja Ruotsin välillä, niin sitä kautta ihan varmasti meillä on paljon parempi näissä niukkuustilanteissa ennen kaikkea tämä kantaverkon käyttövarmuus. Euroopan unionin tasollahan katsotaan niin kuin Euroopan näkökulmasta, että missä ne pullonkaulat järjestelmässä on, ja tämähän on aikoinaan tunnistettu yhdeksi niin kuin pahimmista pullonkauloista sähköjärjestelmästä. Et sitä kautta tietysti se hinnanmuodostus, tämä stabilointi hyödyttää koko yhteistä aluetta.
In Slovenskaya Elektrárnia, we believe that decarbonization of power generation is vital to energy transition and combating climate change. As the biggest electricity producer in Slovakia, we have a long history of construction, operation and maintenance of hydroelectric installations. With the energy transition in progress, intermittent renewable energy sources like wind and solar will add up in the Central and Eastern Europe. To address the grid stability challenge, Slovenskaya Elektrárnia has decided to build on its vast experience and combine hydroelectricity with an innovative approach to storing electricity. In north-central Slovakia, we are introducing SE Integrator, a project aimed to modernize the country's most important pumped storage power plant, Čierny Vár. With an installed capacity of over 735 megawatts, it has been helping to stabilize the Slovak power grid since 1982. SE Integrator is an innovative project aimed to increase the pumped storage plant's efficiency and regulation capacity, as well as hybridizing it with a battery system with a minimum of 70 megawatt installed capacity, which will be able to provide up to at least 105 megawatt-hours of electricity. Combining the fast response time of the battery, backed by the bulk energy storage capacity of the power plant's water reservoir at the same site, it will require no additional grid capacity, saving it for renewables or for the industry shifting to electric, rather than fossil fuel-run technologies.
I am keen on having hybrid projects, pumped hydro with batteries. If you attach 1 hour battery storage to pumped hydro using the same switchyard, you have a very valuable grid stability tool.
Avoiding carbon emissions, SE Integrator will bring new grid regulation capacity, needed during the transition from the soon-to-be decommissioned fossil fuel sources. This evolution of grid balancing will help to bring in more renewables, and to keep out the risk of blackouts. The project is in common interest of the countries neighboring with Slovakia, since the additional regulation capacity will be shared through the MORI and Picasso platforms. The environmental impact of SE Integrator is negligible, because the battery system would be located on site of the original pumped storage plant, which will also get a turbine upgrade. The project is a crucial contribution to the implementation of the Slovak Integrated National Economic and Climate Plan, and it plays an important role in the Fit for 55 and Repower EU strategy. On our way to reaching the climate goals, the existing power and network infrastructure will crave for cost-efficient and environmentally friendly answers to the challenge of decarbonization. Our answer is SE Integrator. Clean, smart, and flexible.
Europe is making its way towards a climate-neutral future. To achieve this goal, it will need to import 10 million tons of renewable hydrogen by 2030. More than 40% of this target could be reached thanks to production centers in North Africa, where solar and wind are abundant resources. But how will Europe and North Africa be connected? The solution is called South H2 Corridor, a 3,300 kilometer dedicated hydrogen pipeline linking North Africa, Italy, Austria, and Germany. It is developed by the 4 European transmission system operators for gas: SNAM, TAG GmbH, GCA, and Bayernets. All the individual TSO projects were included in the first list of projects of common interest under the revised 10E regulation published by the European Commission on April the 8th, 2024. Being part of the European hydrogen backbone, the South H2 corridor plays a key role when it comes to establishing an interconnected and diversified hydrogen market. Significant CO2 savings will be achieved in all countries, thanks to the supply of large quantities of clean hydrogen to the main hard-to-abate demand clusters along the route. The South H2 corridor uses existing infrastructure for over 65% of the route. Repurposed natural gas pipelines are the most effective, competitive, and sustainable transport method. This ensures the effective supply of hydrogen at competitive prices. Thanks to a significant transport capacity, the South H2 corridor will give an important contribution to achieving European and national climate goals, as well as diversifying hydrogen import routes, ultimately ensuring security of supply.
Implementation of smart grid infrastructure is key for development of European energy market. The projects Econ and Danube Ingrid focus on mass deployment of cutting-edge smart technology. This will enable to monitor and manage grids remotely, which means that the grid parameters can be flexibly adjusted and the failures can be managed efficiently. The projects focus on strengthening cooperation between distribution and transmission system operators, both on national and cross-border level. This will speed up modernization of our electricity grid and will enable high capacity for integration connection of renewable power sources. We are installing smart devices which will increase quality and security of supply, which means better reliability for our customers.
Arola Line on voimajohtoprojekti, joka yhdistää Suomen ja Ruotsin sähköverkot toisiinsa. Sen pituus on yhteensä 380 kilometriä, josta Suomen puolella 200 kilometriä. Suomen puolella se alkaa Muhokselta, menee Keminmaan kautta Tornioon, jossa ylittää rajan, ja Ruotsin puolella se jatkuu siitä Jokkmokkiin, ja siellä olemme Messaaren sähköasemalla. 152 kilometriä otetaan käyttöön jos nyt 24 syksyllä. Ja sitten se viimeinen osuus Keminmaalta sinne Ruotsin rajalle ja Ruotsin puolin niin valmistuu 25 vuoden lopussa. Siis totta kai tämä on valtava iso hanke, iso voimajohto, se on jaettu useampaan osaan Suomenkin puolella, mutta sitten suurin haaste tässä on ollut se, että täällä on hirveän paljon soita ja siellä on paljon pehmeikköjä ja rakentamista ei ole voitu tehdä kesällä ja syksymärillä. Suurin osa rakennustoista on jouduttu tekemään roudan aikaan eli talvipakkasilla. Ihanteellinen keli on sydäntalvella, kun päivä alkaa pidentyä, että on pitkät päivät tehdä töitä, mutta maa on tarpeeksi jäässä, että päästään kulkemaan eikä aiheuteta maastovahinkoja. Ruotsalaisten kanssa meillä on ollut tiivistä yhteistyötä heti alusta lähtien. YVA-vaiheessa varsinkin soviteltiin aikatauluja ja niitä, miten toimitaan ja miten edetään. Ja sitten nyt rakentamisen vaiheessa meillä on kummallakin puolella omat projektit, mutta sitten meidän täytyy totta kai sovittaa se Tornionjoen ylitys, että saadaan aikataulutettua sillä tavalla, että kaikki menee hyvin.
Aux origines, il y a un lien, une histoire, un héritage commun entre les deux territoires. Le projet Celtic Interconnector s'inscrit dans cette culture celtique qui, aujourd'hui encore, unit l'Irlande à la France. Responsable et solidaire, Celtic Interconnector reliera les deux réseaux électriques et plus largement connectera l'Irlande à l'Europe. 575 km de câbles qui faciliteront le développement des énergies renouvelables et participeront à la construction d'un avenir énergétique faible en carbone. 700 MW qui contribueront à une électricité plus sûre, plus durable et plus avantageuse pour les deux pays. Unis pour accompagner la transition énergétique, RTE et AirGrid se sont engagés à minimiser l'impact sociétal et environnemental des infrastructures en menant en amont études techniques et concertations locales. Aujourd'hui et jusqu'en 2027, des deux côtés de la mer Celtique, des femmes et des hommes s'activent à déployer l'infrastructure d'un projet reconnu d'intérêt commun par l'Union européenne. Celtic Interconnector, la liaison électrique entre la France et l'Irlande.
Si chiama Elmed. È il ponte energetico tra Italia e Tunisia che Terna e Steg stanno progettando per collegare due grandi sistemi elettrici, quelli di Europa e Nord Africa. L'interconnessione energetica e il collegamento delle fonti rinnovabili alla rete sono fondamentali per un sistema elettrico euro-mediterraneo integrato, sicuro e sempre più sostenibile. Elmed è la prima interconnessione in corrente continua tra i due continenti. Un'opera da 600 MW di potenza e 220 km di lunghezza che sarà realizzata tra la stazione elettrica siciliana di Partanna a Trapani e quella di Mlabi in Tunisia. L'attenzione al territorio e alla sostenibilità è un punto fermo dell'infrastruttura, che coniuga soluzioni tecniche all'avanguardia e minimo impatto ambientale. La tratta sottomarina dell'opera prevede la posa a circa 800 metri di profondità di un cavo lungo 200 km che raggiungerà la costa tunisina, nella penisola di Capo Bon, attraversando il canale di Sicilia. Un'opera di interesse europeo che nel 2022 ha ottenuto un finanziamento di 307 milioni di euro dal programma Connecting Europe Facility. Per la prima volta i fondi comunitari per la realizzazione sono stati assegnati, oltre a uno Stato membro dell'Unione Europea, anche a uno Stato terzo. Un progetto concreto che si inserisce nell'ambito degli obiettivi internazionali per una transizione energetica e digitale che sia anche equa, inclusiva e responsabile.
Hello?
It's much better. Good afternoon, ladies and gentlemen. Welcome to another panel. This time round, we will focus on the action plan for grids. It's a pleasure to be with you today. I'm Łukasz Koliński, Acting Director for Green Transition in the Directorate General for Energy at the European Commission. It's our last panel of these exciting 2 days. And we are focusing on a plan that was adopted almost a year ago. In fact, the end of this month will mark a very special anniversary because it was in November last year that we adopted this action plan for grids. It complemented the new legislation. As you know, we have quite a few pieces of legislation adopted under this framework of Fit for 55, including the Renewable Energy Directive, which had quite a few provisions related not only to renewable generation or storage, but also to grids. And the objective, the common objective of the legislation and of the relevant provisions in the legislation and this action plan is to make sure that our electricity grids operate more efficiently and are rolled out faster. And just as a reminder, what were the main areas of action of our action plan? First, we focused on further supporting the EU PCIs. We focused on enhancing network development planning at both transmission and, for the first time, so much at the distribution level, and we will discuss this in particular today. We focused on introducing regulatory incentives such as anticipatory investments. We promoted adequate financing models and the use of available funding opportunities. And finally, we focused on accelerating permitting. There was also a part which is a little bit aside, but also as important, related to supply chains for the grids development. Together with other entities, such as Acer, EU DSO entity, and SOE, as well as many other stakeholders, we as the Commission, we've been very busy implementing this action plan. We will continue this collaboration to conclude the implementation of the action plan next year. And I'm very glad to say that we have seen a lot of attention focused on grids since the action plan was adopted. So the Energy Council conclusions on grids were adopted under the Belgian presidency. An informal event on grids took place under the current ongoing Hungarian presidency. The critical role of grids was highlighted, as it was many times mentioned during our PCI days, in the Draghi report. And finally, the grids were also mentioned in the mission letter which the President of the Commission directed to the Commissioner Designate for Energy and Housing, who, while we meet here, starts his hearing in the European Parliament. In today's discussion, our distinguished panelists will share their reflections on various aspects related to the actions and the implementation of the Grid Action Plan. And I have the pleasure to introduce them. We have Mr. Peter Vermaat, who is Secretary General of the EU DSO entity. We also have Mr. Raf Bellers, Director of Network Management in Fluvius. We have Mrs. Patricia Labra, the convener of the TYNDP steering group in NSOE. We have, for Acer, Mr. Jan Kostevts, team leader for energy infrastructure. And finally, we also have Mr. Tomasz Sipos, who is the project leader in the Smart Grid PCI ACON. I'll move here to kick off the panel. And I will start perhaps first with a kind of warm-up question. Very quick reply, please, if you allow. In the action plan for grids, what do you personally find as the most relevant for supporting the Europe's distribution grid, something that we now focus on much more than in the future?
Yeah. Not sure. Yeah, this works very well. Yeah, thank you, Lucas, and it's a pleasure to join the panel today. Thank you for inviting us, including two of our members, Thomas and Raf, to discuss the distribution grid. And when I look back, and you ask me what is the most relevant or the most, let's say, acknowledged development in the past year, let me first go back indeed 1 year, a little bit more than 1 year. In the very same building here, we had this high-level grid conference in September, and then it was quickly followed by the grid action plan. And to our feeling, that really sparked the grid momentum, let's say roughly 1 year ago. And I think we have all seen that since then, the relevance of the grid has been acknowledged very widely, including a separate seminar, I would say, in this part of the PCI Days today. Now, like you illustrated, the Grid Action Plan, in fact, covers the entire value chain, investment, supply chain, permitting, a lot of things, and it was a pleasure for us to join forces with the Commission and other stakeholders to work on it. When I pick one of the things now to elaborate a bit more, I would like to refer to the acknowledgement of the need for investments. I think everybody is clear now that the investment is not about expanding capacity only, but also about smartening the grid. So there are two dimensions to it. But also in the past year, I think it came much more paramount that we are not only talking about huge investment and used cost, but also about a very high value.
Indeed.
The value actually for the energy transition as such, but also the value in creating the competitive conditions for our industry to survive to the future. And in expanding the grids and smartening, there is also the economic growth that enables our suppliers to develop their own capacities. So there is a sort of double benefit, and I think we have realized that all the more, even looking at the upcoming mission letter and other dimensions of the new policy.
It's recognized there. It's absolutely there. So the investment dimension. Please, very briefly, because we will come back to all these topics during our discussion.
Okay, thank you. For me personally, I think it's a great benefit that in the action plan there's attention for the supply chains, supply chains for the grids especially. I think until now, if we talk about energy transition, I have the feeling that looking at the industry, we're talking about PV on heat pumps and so on. Of course, they are very important in the energy transition, but if we don't have the key components in our grids like transformers, cables, the switching gear, of course, we won't succeed in realizing the energy transition. So for me, the attention given to creating and safeguarding the production capacity for these components as well is very important.
Slabra?
Thank you. Thank you for the invitation. And it's maybe it's also very similar. I believe that investing in infrastructure is essential for preparing distribution and transmission grids. That is aligned with the Action 13 of the Grid Action Plan that emphasize the collaboration with technology providers, to prepare an efficient supply chain ready to support the energy transition. That requires an enormous collaboration among sectors, borders, and stakeholders, and that's what we are pursuing also, because at NSOE we have collaborating with EU DSO entity, with Europa Cable, and with Transmission and Distribution Europe, to address this supply chain bottleneck, in order to give visibility of what is the grid project pipeline, to help and facilitate the investment in manufacturing capacity. I could also mention the shortage of skilled staff. And before closing, if I may, I will also mention the Action 7 of the Grid Action Plan that stress the importance to build a smart grid and efficient grid, and in that sense also to highlight the collaboration between EUDSO entity and NSOE in the Technopedia project that tries to give a hint of what are the innovative technologies that can be used to solve the current and future needs.
Absolutely, thank you.
Thanks also from my side for the invite. Agreeing with what was said with the colleagues, but an emphasis maybe on our side, on Acer side, is one on the efficiency aspect that you mentioned, especially on the putting sort of the finger down on incentives as a major tool to incentivize efficiency. The other are, of course, DSO planning in general and DSO guidelines that we, together with the NRAs, are supposed to work on.
Thank you.
Thank you very much.
And the smart grids, right?
Yes, absolutely. As a promoter of 2 successful PCI smart grid projects covering 3 member states and reaching almost 800 million euros, I'm definitely voting for the recognition of the importance and of the role of smart grid PCI projects. So far, PCI smart grid projects have been a very small category compared to TSO projects, but I think that also the raising importance of these projects is going to bring more of these kinds maybe for the next PCI PMI list. So definitely smart grid PCI.
Thank you. Okay, now let's develop some of these topics a bit further. EU DSO entity plays a key role in the implementation of the action plan in capacity building and also sharing of best practices. 1 year after the grids action plan, what achievements of your entity and what challenges you would like to highlight?
Yeah, thank you. That's a very nice question. I think if you look at the 14 action points in the grid action plan, 7 are focused also on the DSO contribution. So we had a nice challenge to get it all started last year in a certain sequence. So we were not able to do everything in one go, but by now I think we cover the entire portfolio. And if I may mention a few, and I think Raf will elaborate on some others, but I think that a very relevant development was that we looked a bit more in detail into the character and the development of the distribution network development plans. I think Patricia was already referring to the T-Way NDP, right? Now, in a way, the distribution network development plans have a different granularity, but still they can give good guidance to efficient investment planning and for the suppliers. So I think it was nice that the action was there, so it challenges us to do a bit more, and we have already produced 1 or 2 papers on that, and there is more to come. Even, I think, Jan, another workshop tomorrow, right? With Acer on the DNDP, so a lot of work there. A second one, and that's my last example, I can give more if you like, but I'll keep it concise for the moment. We have also worked a lot on the paradigm of anticipatory investments. We have discussed that with policymakers, with regulators, and I think apart from acknowledging the need of the efficiency of anticipatory investments, we have also learned, and that is also a dialogue with the regulators and policymakers, that it requires a new paradigm. Because in the old world, both DSOs and regulators were focused on, if I may summarize, like controlling risks. Now, under the developments and the rapid acceleration of energy transition, we need to look at it from a different angle. In fact, we need to learn how to manage uncertainties and play with that and then still make a decent and efficient investment plan. So from controlling risks to managing uncertainties is a sort of new paradigm that we try to develop, and hopefully in the year to come we can come to a good view and a good interaction with the other stakeholders on that one.
Thank you very much. A question to Mr. Bellers. With growing demand, DSOs need to accelerate the grid build-out, obviously. Could you give us an example of what DSOs can do to streamline practices such as procurement?
Yes, of course, I can give you some examples there. First of all, I think I mentioned before, this is for us a very important topic, being DSOs. And it's also confirmed by a survey that was done by the EU DSO entity between its members. And it showed that, for instance, 60% of our members have some issues in building out for capacity for solar PV due to the supply chain challenges that they met. So I think it's something that keeps us awake and doesn't mean that we are not acting and we don't have any good example with regard to dealing with this issue. I think in the same survey it showed out that there of course are some good practices, and it's DSO entity will of course share these good practices so that we can all inspire each other and that we can elaborate on this. Some examples. What we see today that they are at different levels and between different actors, and they are mainly in two categories. First of all, trying to streamline and align the technical specifications so that there is more resilience, that there is more exchange possible between the components. And the second one is also to streamline procurement rules or even go towards joint procurement. Sometimes this happens through national associations. For instance, in Poland, we saw that there was a unified certification program for power system automation. Sometimes it's done even between TSOs and DSOs. I think that's also very important that we have these examples. We have the example between German TSOs and the Austrian DSO Wiener Netze about maximum voltage cables. Sometimes it's all about DSOs having branches in different countries, and trying to align also between these different branches, between specifications and procurement rules. And of course, at the end, we also have examples where we can find that there are some cross-country alliances that arise to get and to align technical specifications, for instance, with regard to smart meters. With regard to procurement, I can give the examples of the Netherlands, but also in our own case here in Belgium, where we do joint procurement between DSOs, sometimes also including TSO. And this has two benefits. First of all, it's the joint market, giving more insight for the supplier about the volumes that they will have to produce, but also it forces the DSOs to come together and to discuss the specifications and try to align, otherwise it's not possible to go to a joint procurement. So I think there are a lot of good examples already there. We are not there yet, and I think one of the reasons that maybe it's not going that fast as we would like it to go, we have to be aware that we have a large or long history before, and grids were built up a long time ago, so we have very differences very locally due to historical reasons. And it's also, like Peter mentioned, we were used to, and this is still very important for us, to deliver a reliable grid and safeguard also the safety of our technicians. So I think every time we have a discussion about technical specifications, every time we have discussion about rules of procurement, these two things pop up, and we need to have this change in mind of the people dealing with this, how to overcome, to be assured that taking a new or another specification is as reliable as the one that we knew from before. So that's, I think, an important rule for us internally between DSOs to look how we can deal with it, to get this change also in our minds. And then it's a bit like going from risk avoidance to management of the risk. And another thing is that maybe on procurement rules, I think there we could use some help from EU. We are also bound by legal documents there. And I think looking at ways to simplify and to get more aligned procurement rules between different countries could help us also to move forward in this perspective.
Thank you very much for highlighting this need to adapt the mindset, adapt the action, because this is what leads us to another question to Ms. Labra. We have more and more distributed assets in the system, more and more users who are connected at the distribution level. How the TSOs and DSOs should adapt their practices in terms of planning in view of this change that is happening?
Okay, well, you are right, Lucas. More and more users will be connected to the distribution, but also to the transmission level. And when we talk about users, we talk about not only new generation, but demand storage. So it's quite variable, yeah. So that will mean that in practice it will mean a change of pattern flows that we will have in the future, and the system and the global system will change. And for sure, we need more coordination between TSOs and DSOs on this, perhaps with new practices or reinforcements. Current practices. For instance, we recognize that probably grid planning is one of those areas that we need to reinforce. Integrated planning will be very useful to have a wide view of what will happen in the system of the future. And that will allow us to identify what's the better design of the system that we require to address the future needs. And to that end, EU DCO entity and NSOE have signed a memorandum of understanding in 2022 to solidify their willingness to work together in certain areas. And I would give some examples of those areas of cooperation that are considered, such as the development, implementation, amendment, and monitoring of guidelines or grid codes, or the exchange of best practices in operation and planning, both in the distribution and transmission systems. Also, we have a common work plan for 2024-2025, and we have there 4 key areas that we have detected that will have main changes in the future, and those areas are energy system flexibility, the operation of systems, grid infrastructure, and empower consumers through the digitalization. So I guess that as you can see, all those key areas are fully in line with the electricity market design reform and the EU Grid Action Plan. So we are collaborating. We have to improve our collaboration and go on with it for sure, but we are adapting, and I guess that's also the regulation has to adapt, also to give a clear guidance on what are the TSO-DSO responsibilities on grid planning, on cost sharing, on data ownership, and some others.
Indeed, thank you. So let's take it further now, moving on to regulatory authorities and their role. It's crucial in incentivizing the right investments at the distribution level, not only in terms of capacity, but also in terms of smartening of grids. So in your opinion, Mr. Kostevs, what are the key actions that the regulatory authorities could take in order to incentivize these right investments?
Okay, thank you. I would separate these groups of investments as you did, right? So we have the so-called classical investments into infrastructure. I think system operators on the TSO side and DSO side are already doing it rather well. Of course, facing challenges, but I think these challenges, most of them on the DSO level, can be met with good planning. I think this is maybe something that needs to be developed. Of course, this is something that we're going to discuss tomorrow in the workshop, but it's something that deserves lots of attention. I think planning on the DSO level in some DSOs is done quite well, and they can benefit from it. In some other DSOs, it's done rather poorly, or at least can be much improved. And then that part, I think, can tackle many of the issues from supply chain to what we are calling anticipatory investments, and so on. On the smartening part, which I would rather call to try to make the grid more efficient, of course, it's usually done through smartening it. That is more on the regulatory side, to try to create a framework which would allow or incentivize the system operators to move into this direction. Because most of the remuneration of system operators is still focused on remunerating assets. So it's fully RUB-based, if we use the abbreviation that we usually do. And here, if you're talking about low cost or even zero cost investments, we need to find new ways of how to remunerate that and look at the value that they bring and not the costs that they incur. I think these are the elements to truly work on, again, DSO planning, the first step for classical investments, and then creating a framework, an environment where also smart investments to aim towards efficiency would prosper and actually use digitalization, all that in these regards. Thanks.
And indeed, smart grids are particularly important for the integration of renewables and also integrating electromobility, storage and other solutions for flexibility. In your mind, are the DSOs sufficiently focused on making their grids smart and enable the integration of these assets?
Yes, thank you very much. I think it is very important to also to understand and to clarify that a smart grid DSO project is really a project putting together several hundreds of investments at DSO level to be really planned and coordinated during a given time frame. Usually smart grid investments have the duration of 5 to 6 years, so it really requires DSOs to have also the inclusion of the already mentioned anticipatory investments, to have the inclusion and the reaction of the foreseen development, not only on the energy market, but we also need to see changes when it comes to the general climate in Europe. For instance, our first PCI project, the project ACAN, it was developed in 2017 and 2016. It was a completely different environment when we are speaking about e-mobility, about renewables. Then our second project, the project Danube Grid, it was successfully listed in 2020, and it was already after the clean energy package was adopted in 2019. So we had to react on completely different circumstances, but in the meantime also to have a sense of visionary view on the market, how it is going to develop. And I can really say that seeing also the physical assets that are going to be built up during this PCI project, it's really creating the platform for the future grid users. Because in 2016, 2017, we were speaking about only about, in terms of grid users, about consumers and about producers. Now in 2024, I mean, the providers of flexibility, aggregators, energy storages, energy communities are already integrated part of all the energy grids, and distribution companies needs to be ready for this transition when it comes to the energy market. We cannot be the subject on the market who is blocking the development. So therefore, I think that it is very important and crucial to have a well-prepared PCI smart grid projects, because I think, yes, to answer your question very clearly, PCI smart grid projects can react in terms of creating the capacity, in terms of better management of the already existing capacity in the grid that we can approach by adding smart devices to the grid. That is part of, I think, all of the smart grid projects generally. And using these devices, as it was mentioned also by Jan, we can really have better management of the grid without having the need of massive capex investments. But on the other hand, also to employ the ultra-fast chargers, or to employ new capacities when it comes to energy storages or even the renewables. We cannot rely only on smart investments, but we need to make also heavy grid investments to have new substations, to have a new transformer capacity. And the status of the PCI projects, in our case, it very clearly demonstrates that yes, thanks to the PCI status, we can make very heavy investments in a very limited time frame to happen, because without having the PCI status, also the permit granting would not be probably so fast. Also in terms of co-financing, that we are very glad that also the European Commission co-financed most of our projects. We can have these investments to happen in a very limited time frame of 4 to 6 years. And this is then really enabling the development of the next stages of the market. And also in our cases, in case of these 3 member states that we are covering now, Czech Republic, Hungary and Slovakia, I think that all the partners also from the distribution company are in contact with the relevant ministries in order to align our investments also with the challenges that we are facing now in terms also of the climate change, but also of the energy transition.
Thank you. Would any of the speakers want to react quickly to anything that was said in this first round before we get to the second?
Yeah, perhaps if you invite us, I think many nice things have been said also about the cooperation between DSO entity and NSOE. But I think I would like to add a little bit also to the observations of Jan Kostevs, because I think indeed when looking forward to the regulation of the income of DSOs, we also need to change a little bit the way we approach it. I think it's nice that you introduced that we need to look at the value, perhaps not only at the cost. I think also we need to make it a bit more forward-looking, because indeed partly it is RAB based, right? So the asset base is the starting point. But in a time of rapidly increasing asset base, sometimes you are lagging behind if you look backwards rather than forward when defining the income. And thirdly, there is the dimension of the operating cost. I agree, not everything should be CapEx, right? Let's be efficient. However, let's not forget that, for instance, by digitization, we also introduce a lot more operational cost, because exchanging the data is a very high, has a very high operational component in the cost. So I think, yeah, there are many dimensions to look into, and happy to join forces with Acer and see the efficient way forward. We always like to be challenged to be efficient, no worries, but we should acknowledge that there are some increases that are unavoidable.
Thank you. Okay, let's then move on the other growing issue, I would say, the connections, and the question to you. DSOs receive many connection requests every day, basically, and there is a lot of expectation of these connections to be provided as quickly as possible. How can we make sure that we correctly address this growing challenge?
Yeah, indeed, it is a fast-growing challenge, and it also illustrates that the investments we make are also there to distribute and transport a lot more energy than we are used to in the past, right? So the electrification is driving also the demand for connections. You can imagine that there are many more connections to be requested than before. Not only new connections for charging poles or for solar farms or wind farms, but also existing connections that need to be upgraded to a higher capacity. And for both of them, we need to invest in the grid. So not only simply making the connection as such, but also strengthening the grid capacity. Now, the way to do that is, on the one hand, we need to smoothen the procedures for the connection. So we are trying to digitize and give a faster response to know when, if a connection is possible and when it is possible. But I think there is another dimension that is super important there, because what we can see now is that there are some rightful, justified connection demands, but there sometimes are also I'm not sure if it's the good English word, but there are ghost demands, right? So people ask for a certain capacity just in case. So you can see that the illustration of congestion, which in fact is part of the success, because the penetration of rooftop solar and wind farms creates the congestion a little bit. But to be sure, people ask for more capacity than really needed. So it is queuing in a way that it is not really the exact value that we need to work for. So that is what we need to learn to distinguish a bit better. I call it the overestimate, the ghost. And there is another part, and that is even more worse. There is the speculation. We have even seen cases that people speculate to ask for a connection, and they sell it to the neighbor at a profit. And so that is also, we need to look into it from an optimistic, positive view. But let's not forget that we need to filter out a little bit the things that are not correct.
But there are already some practices, at least in some countries, that try to exactly eliminate this type of issue.
Yeah, no, so indeed there are countries that are already experimenting with that, also by verifying the nature of a request and other things. And a very important element there, I think, is also that together with authorities, we redesign the prioritization of connections, right? So that with the authorities together looking to the societal benefits, we also try to prioritize not only the size of the connection, but also the priority for certain industry sectors, or for instance for hospitals or schools, that we have the correct priorities there. And also there, I think also with the regulators, we are working on improved regulation to give clarity and make the right choices.
Thank you. looking at the example of Fluvius, when you're planning the network, how do you make sure that you correctly reflect the need for electromobility assets, heat pumps, etc.? You know, taking into account the diversity, let's say, of assets on the other end.
Yeah, this is of course a very important. Because, very important issue because this will drive, of course, our investments. The need that there are not only for connections on the demand side, maybe, but also. Hello, yeah. Not only in demand, but also on production side and all the connections, and this demand will, of course, drive our investments. Now, what we do within Fluvius is that every 2 years we create a 10-year looking forward investment plan, taking into account all the predictions we have in different scenarios with regard to what will be the increased demand, what will be the increase of production, for instance. And we do this by having a lot of debate with all possible stakeholders that are involved. We have debates with the associations, for instance, from mobility. There's a connection between mobility and energy that is created. So we try to get a common view and an agreed view on possible scenarios towards the future. What will be the evolution of penetration of photovoltaics, solar, for instance, and maybe, yeah. And also with electrical vehicles, we do it with our associations here in Belgium to get a good view on the prognosis for the evolutions there. Also with the industry, and maybe that's the most difficult for us to get a good view on what is the evolution in industry and electrification in the industry. Today, I must say, this is for us still a big question mark. Well, we try to fill it in, but there's a lot of uncertainty there. And we have to deal, like was mentioned before by Peter, we have to deal with uncertainty. So it doesn't hinder you in starting investing. You don't need to be sure of what will be the amount of solar. Maybe I can switch.
Change the mic. Thank you.
Yeah, it's better. So you don't need to be 100% sure about what will be the level of solar PVs within 10 years to start investing now. That's why we call this a no-regret investment plan that we are building up. And we revise it every 2 years. Again, with all stakeholders, having the debate, checking whether what the assumptions that we made before are still the right assumptions, whether reality is different than what we assumed, and how we should change our prognosis for future and the scenarios there. And you can work also with different scenarios, high, low, medium, and agree on what scenario that you will take into account in your calculations. By the way, we do the same exercise with our TSO, of course, but at the end we come together. And we have to have the same assumptions, because otherwise you will have discussions and you will not do, let's say, synchronized investments at the both levels. So it's really important to have these discussions with all possible stakeholders, do it regularly, don't bother too much about what is the exact number within 10 years, but it's good enough for now, let's start investing. And meanwhile, of course, think also about other solutions than investing. It's mentioned here already, smart grids, flexibility solutions. We still have some time to do also the necessary investigations. We do this via different exercises at this moment, trying to find out what will be the impact, because especially if you're going to look at the distribution grid, it's different than at the transportation level, because you have the aggregation of possibilities for flexibility is less at a level of a low voltage grid than at a transformer station, for instance, where you have a larger area where you can find your flexibility. So it's always getting a good insight with a lot of communication and debate with a lot of stakeholders, and trying to translate this to what does this mean for our system, and take this into account, but start investing also just to be ready before the question comes and not afterwards, because then we are too late.
So, moving to ENTSO-E, when you're preparing your 10-year network development plan, how do you take into account these changes at the distribution level?
Well, the TUNDP focus primarily on cross-border transmission infrastructure, right, that accommodates high voltage power flows across Europe. Yeah, I guess that you all know the TUNDP, and you know that it's a plan that is required by the regulation, and that gives a wide view of what will be the energy system will look like. Yeah. The TUNDP also make an assessment of what the projects can provide to the society, and let me give you some of the data of the latest TUNDP that have been published in 2022. There we can see, or what our study shows is that investment in around 6 billion euro per year through 2040 horizon would give benefits to the European society of around 9 billion euro per year. Yeah, in generation cost savings, which is quite relevant. And those investments also would allow to integrate 42 terawatt hours per year of renewables, of renewable energy sources that otherwise would be curtailed, and would avoid around 31 million tons of CO2. So that's are the global numbers that's the TUNDP provide. It's true that is mainly focused on the transmission cross-border infrastructure, because up to now the distribution was more locally focused. Yeah. But it's true that we have mentioned that the system is also evolving, and that recent developments have introduced an increased collaboration to break the gap between the transmission and the distribution. And I would say that there are two main areas of collaboration there. One is the scenarios, and the other is the network models. Yeah. From the scenario point of view, I would say that since the 2022 scenario process, we have been collaborating together with the EU DSO entity, and the idea here is to work on refining methodologies and other aspects, yeah, to be able that the scenarios that we produce also include the perspective of the distribution level and the transmission level. And from the other side, from the network model sides, yeah, when we build our TUNDP, we use the models, the network models that the TSO built at national level, and in that sense, they already include details of the distribution network. So that means that when we try to analyze what is happening in the cross-border infrastructure, we already take into account what's happening in the distribution network. But well, for sure, we have mentioned before the distribution network development plans. So we consider that those aspects that EU DSO entity is playing with the distribution network development plans of give more visibility on them would benefit to us all, because having long-term visibility of what is happening will be able to integrate those data in the global network models, and will be very useful. In addition, it was also mentioned that those distribution network development plans will allow also to give visibility to manufacturers about the grid project pipelines. So that's also another benefit that we have there. Yeah. And related to this, we are already finishing the TUNDP 2024. We are already starting the 2026 edition with the scenarios, and we intend to deep in the collaboration that we have together.
Indeed. Moving to the regulatory level, how in this very dynamic situation, in this uncertain situation, how to ensure that, you know, from the regulatory point of view, you strike the right balance between the adequate scrutiny and at the same time pragmatic, effective approach which doesn't create bottlenecks on the ground?
It's going to be a learning curve for sure for many regulators. I think one of the issues is that regulators, of course, would need to stay on top. That's why they're there, right? They need to regulate the monopolies. However, the implications, especially for some member states, where they may be faced with huge amounts of additional new network plans, can be rather demanding in the current setting of resources. So I think the regulators, alongside the DSOs, and the TSOs probably have something in common. We are all asking for more resources. Unfortunately, without them, it's going to be really hard to tackle. Huh? We have to understand that this is a challenging road ahead, and then we cannot do it with the same amount of resources as we had for now. But I would also count on a secondary layer of scrutiny, which comes from stakeholders. And this actually, if the plans are made transparent, inclusive, if stakeholders, especially those holding knowledge, but also other, interested public is joining these discussions, the scrutiny already comes from that point. We had, I think, interesting and very positive example of that happening in the development of network development scenarios, where through ACER's guidelines, a stakeholder reference group was formed, which may add some complexities to my NSOE and NSOC colleagues when developing scenarios on one hand, but on the other hand, it really helps us out as, a community of regulators, because they scrutinize the development of scenarios from their own perspective, of users of the grid. And I think this part should not be neglected. I think we are saying for quite some years now that the grid should be developed for the people, right? Empowering people in that sense. But to do that, we should do it inclusively. Huh? Thank you.
Thank you. Coming back to Mr. Sipos, and you already mentioned briefly how receiving the status of the PCI helped ACON project to be implemented faster. Could you develop on this? Are there any aspects that are relevant for the discussion that we have here?
Yes, absolutely. At the beginning, just very briefly, I think it is well known, but just to have a common understanding, PCI smart grid projects compared to PCI TSO projects has one very big difference. In terms of TSO projects, we are usually speaking about one interconnector, one investment that is ongoing between the two countries. In case of a PCI smart grid project, as I already mentioned, we are speaking about hundreds of investments that are happening in the same time, usually in two member states. So these parameters of the PCI projects then are triggering also the benefits. And the benefits I can really divide into two groups. One is routing directly from the PCI status of the project, and also the current regulation, but also the previous 10-year regulation is providing several benefits to the PCI project. For us to make the investments of ACON to be completed on time, and just for the audience, we are speaking about an investment approaching 180 million euros in Slovakia and in Czech Republic, happening purely at the DSO level. And the benefit that we gained from the PCI status is, first of all, the public acceptance of these investments. During the whole realization projects, we had no issues with the public acceptance. And it is also thanks to the fact that we had, on a 2-year basis, public discussions. Due to COVID, we were forced to move it to the hybrid dimensions, to have it also physical presence and also online. But these were proved to be very effective, and even though now we are continuing in this platform, so public acceptance definitely point number one. The second benefit routing from the PCI status is also in terms of permit granting. Within the PCI smart grid projects, there are investments, pure investments that do not require any kind of permitting. These are either investments happening within the already existing assets, just changing part of the assets to smart assets or adding smart dimensions to the assets. But then there are also greenfield investments that obviously require permitting. In our case, I think it is quite common for the Central and Eastern European countries, we need also zoning permit and so-called building permit. So there are two different administrative procedures. And thanks to the PCI status, the length of these procedures are limited. So also that the action of the related state authorities needs to happen in this limited time frame. So it was also one of the benefits that we experienced during the realization of the project. And the second benefit from the PCI status is obviously connected then to the financing part, because obviously these investments are very intensive when it comes to financing. And we are very happy that we received the co-financing from the European Commission. And this really provided us with the chance to finish all these investments in a relatively short time. Without these investments, this realization time would be much more extended. And one of the last dimensions that I need to mention, and I'm always using the platforms to underline, is that the PCI project is also making a transition within the company, because you also need to coordinate and harmonize several hundreds of investments to happen, again in a very limited time frame. So it is then also increasing the pressure, and also the discussions that I had with other colleagues from the PCI Smart Grid dimension, they are underlying this parameter that it is changing the internal organization to be able to realize investments within a limited time frame. Mm-hmm. And this is then providing you with benefits also with other mechanisms when you're going to modernization fund or when you're approaching EIB financing. So it is providing a benefit for the company, also for the future investments to be realized in a very limited time frames.
Thank you very much. We have a few minutes for questions from the audience. I'd be happy to take a few. If there are any, could you please raise your hand, identify yourselves. Are there any questions from the floor? I don't see any for the moment. No? I mean, I would perhaps then ask one question. Many stakeholders are mentioning the need for being informed about available grid hosting capacities. How difficult it is to give this information to the stakeholders in all this dynamic situation that we were discussing, how difficult it is to share it.
Yeah, thank you. And in fact, I think you're also referring to one of the action points in the Grid Action Plan. Indeed. In combination with the flexibility methodology of the electricity market design. And indeed, we are working on that together with the other stakeholders, including Acer and SOE. I think one of the main challenges is indeed how to define the capacity in a very distributed way, because in essence, congestion management and voltage control in the DSO grid is a super local business. So we are trying to develop a view, a frame, if you say, a framework, how to make it a meaningful definition and still giving some clues there. But I must admit that at this moment we are only at the first round of consultation. It will be launched end of this week. So take a look, I would say, and then we'll collect the further views in the time to come. It's a good question, but a very challenging one.
That's why we're asking it. Any other comments?
Yeah, I will also agree that perhaps sharing accurate maps of grid hosting capacity is a complex task. And I would like to highlight the wording accurate. And the reason is that so we have different understanding definitions, and because of that we also have different methodologies from country to country, so that means that if we build a map, it wouldn't be comparable. So I guess that we have to go on with a continued collaboration and also possibly regulatory alignments from country to country. It's, as Peter has said, it's something difficult, but it's ongoing.
And I would also emphasize that the work that needs to be done to get indeed this accurate and let's say up-to-date information about the capacity is taking a lot of time internally. We have capacity maps available on the medium voltage grid where you can see what is the available capacity that I still have available, as well from injection as from demand side. But the effort we need to do to keep this map up to date, because things are evolving very quickly, is a large effort. So you have to think about automating this process, and this takes also a lot of time and again, yeah, we need workforce to do this, and so that's also beside the definitions, of course, the work that it takes to deliver an up-to-date capacity map. You may not underestimate it.
Especially also since you also need to know the actual flow of energy, right? So the visibility and the digitization of the grid energy flows is a prerequisite there, apart indeed from contracted capacity. So well, a nice challenge.
It is. The last chance for a question from the audience. No, then I will perhaps wrap up with just a few takeaways. I would say that in my mind, the discussion really underscored the importance of pushing forward with the implementation of the Grids Action Plan. There are quite a few challenges still ahead of us. A lot has been done, in particular at the level of the distribution grids. We do need to move ahead. We need to pay more attention. I think you rightly mentioned the importance of investments in capacity, but also in smartening of the grids, and this done in an integrated manner in order to be as efficient as possible. Quite a few of you mentioned the ongoing change of the paradigm and quite some uncertainty and the need to adapt practices that is driven from this challenge. There is quite some room for streamlining. I'm very glad that we heard about good examples, about quite a few ideas for streamlining cooperation horizontally between the DSOs, but also between TSOs and DSOs. And I think one of the very interesting things that has come out is this need for deeper engagement with the stakeholders in order to figure out what's happening, what's going to happen on the end user side with all these different assets related to industry, to heating, and to transport. And that, of course, is not only creates the challenge for the DSOs, but also a challenge, a learning curve for the regulators. We heard that there is the issue of the engagement with the public that needs to be also tackled better in order to ensure that all these investments come online in a timely manner. But we also heard about quite promising, quite optimistic messages related to the PCI status and how this can help with the acceleration of the investments and including on permitting. So I think that overall, quite an optimistic message. And I think with this we can wrap up. Very big thanks to all the speakers. Thank you to the audience.
Thank you.
We will very smoothly move from this last panel to the closing remarks. Let me say a few words, ladies and gentlemen. It's time to close these PCI days. It's been a very intense and fruitful 2 days, and this was mainly thanks to all of you, your presence, your engagement. I'm delighted to say that these PCI days have attracted a record number of participants ever. Let me try to just highlight a few points from different discussions that we had, starting with the lessons learned from the Connecting Europe facility as a catalyst. When we discussed this issue yesterday, the panelists obviously agreed that there is a need for more grids in order to fully benefit from the internal energy market, in order to integrate all those growing volumes of renewables, in order to electrify further. And the participants also agreed that we need more funding for, more EU funding for cross-border grids in order to address this investment challenge. Obviously, the role of the private funding is extremely important, but there was quite a few arguments, we heard quite a few arguments how the Connecting Europe facility has done a good job in order to de-risk these very challenging cross-border projects. Also, the panel members highlighted different avenues for making CEF more effective, the stability of the policy, stability of funding, crowding in private funding through, for example, blending. The panelists also called for better data collection at the European level to accurately map the grid needs, and a more top-down approach for identifying the most important cross-border projects that are needed from the EU perspective. Another panel discussed maximizing the benefits of regional cooperation for a secure and affordable energy transition. And there, the panel members highlighted the key accomplishments of this regional cooperation in the regions that we have seen. Also, the role of facilitating role of the Commission was considered quite critical for these achievements, for stimulating these discussions and the progress. And I'm happy to say we will continue, obviously, to be involved in that. We heard also about the multiple opportunities from the exchange of best practices, from the strengthened cooperation. Then today we had the panel on powering the future exchange of best practices and challenges related to hydrogen projects specifically. And there the panel members stressed that timely implementation of hydrogen infrastructure is obviously essential for developing a cross-border hydrogen market, a priority for the EU for the years to come, in particular for those sectors which cannot be electrified quickly. And achieving this requires, according to the speakers, the following: stronger integration of the planning processes across hydrogen, electricity, and natural gas sectors, transparency and increased incentives on the hydrogen demand uptake, and closer regional cooperation between the member states, between the regulators, and between the promoters in order to align regulatory frameworks and coordinate essential support, such as was mentioned here, on permitting, on financing for the timely deployment of this infrastructure. And then we had, I would also mention that the panel members expressed a wish for a dedicated European hydrogen infrastructure action plan to accelerate the development of Europe's core hydrogen network, something for us to reflect on. We had a discussion on the Pact for Engagement, and there clearly, as was also reflected in the last panel, public engagement is considered as important for grid acceleration because the issue of public acceptance remains one of the factors affecting the timely completion of the infrastructure projects. We had 24 companies and associations co-signing the Pact for Engagement today. We are grateful to their commitment and encourage them to keep up their efforts on engaging the public to develop the infrastructure projects and advancing the transition. The Pact included guiding principles for early public engagement for the development of energy infrastructure projects, which reflect a common ground on how this should be done in the right way. As the Directorate General for Energy in the Commission, we are going to continue steering this process to drive public engagement forward at a European level, and we invite all of you to participate in this process. And then we had very fruitful, if I may say so, PCI garden talks on gearing up for the future. We heard innovative stories and technology use cases from project promoters covering the whole energy sector, from electricity through hydrogen to CCUS. Panel discussed ways how could we design future projects in a resilient way from both physical and cybersecurity point of view. The project promoters also highlighted that the interconnectivity in terms of physical infrastructure is still crucial and brings value for money. It also provided for higher resilience in cases of natural disasters, and this climate adaptation and the related emergency preparedness has been considered ever more crucial. Two dimensions were highlighted: long-term adaptation to changing conditions, such as the rising sea levels, for instance, for offshore projects, as well as short-term adaptation to weather conditions, which may significantly affect the immediate operation of the assets, as well as not so obvious things, such as the annual maintenance schedules. When it comes to cybersecurity, we should not forget about the human factor. Regular training, but also testing, is critical to maintaining stable operations. And then we had, obviously, our last panel, which I summarized a while ago. So let me say before we close that I would like to thank all of you once again, all the participants, for their engagement and being here in Brussels with us. Big thanks, of course, to all the speakers for sharing your knowledge, your views, and your thoughts. Huge thanks to the promoters in the PCI Garden for your availability, your engagement, and your dedication. Your projects are the live examples of the success story of 10E policy. And last but not least, I would like to thank the team in the European Commission and in CINEA, who are behind the organization of this exciting event. And I look very much forward to seeing you all next year at the next PCI Days. Thank you very much.